Good morning, everybody, and welcome to the info session on the EFSA Big Guidance document 2023. Next one. So, sorry, we have having some technical problem with the slides. I hope that now is okay. Okay. So before starting, some housekeeping rules. You are connected to the audio broadcast, only one way audio. So you can only listen us. The event is in English, and the question should be submitted in English with the Q&A chat box that you see at the right of your screen. Anyway, the event is going to be recorded, and the recording will be published on the EFSA website just after the event. And you also, all the attendees will receive a link to a survey to evaluate the EFSA event and the services. Next one, please. Okay, so I would like, first of all, to introduce the agenda of this event. So we will have three sessions. The first session, we will have a presentation on the specific protection goal, on the overview of the guidance document, and the first presentation on the chapter 5 on the exposure. Then we have first the Q&A sections related to those presentations. Second presentation, we go through the lower tier hazard, the lower tier risk assessment, and the time reinforced toxicity. At the end of this free presentation, we will have a coffee break. We will have a second Q&A, and then after the second Q&A, we will have the coffee break. Then we have a third session where we go to the scheme for sublethal effects and higher tier studies, and then we have a third Q&A, and then we end the info session. So during the Q&A, we will answer to some questions that have been received with the registration, and also we will answer to some selected questions from the chat. So we would advise you to make a question for clarification related to the slides, and to make a question as concise as possible in order that we can address as many as possible questions for clarifications. I also would like to ask you to submit your questions at the end of each presentation, and if possible, also please tag the speaker, because some of my colleagues are going to screen your questions and select a couple of them that can be answered from all the speakers during the Q&A sessions. So the question will be only answered during the event, so we are not going to provide a written answer to all the questions that have been received during the registration and during the event. Next one, please. Okay, so I would like now to start with the first session, and in this session there will be three speakers. Sophie Hofkens from DG Santé, then I will present the overview of the big guidance, and then Csaba Szentes will present the exposure part. So I give the floor to Sophie for the first presentation. Sophie, the floor is yours.
Okay, thank you, Mima. And first of all, I would like to congratulate you and your team with the publication of the guidance document and express my real appreciation for all the hard work done. A big thank you. Good morning, everybody. My name is Sophie Hofkens, and I'm a policy officer at the European Commission in DG Santé, Unit E4. That is the unit who is, among other things, responsible for Regulation 1107/2009 on the authorization of the approval of active substances in plant protection products. We also refer to that regulation as the PPP regulation. And I will talk to you today about the setting of the specific protection goals and also about the next steps. Next slide, please. But first of all, I would like to remind everybody of the current status of a bee risk assessment for pesticides in the EU. And that is the 2002 guidance document on terrestrial ecotoxicology, 2002. So I think we can all agree that the reinforcement of the risk assessment for bees from exposure to pesticides is really necessary. And already in 2013, EFSA published a guidance document for bees, but that was never fully endorsed by the majority of member states in the Standing Committee, Plants, Animal Food and Feed, despite really several efforts over many years. And that's why Commission mandated EFSA in March 2019 to revise that guidance document. And taking into account all scientific knowledge that already had emerged by that time. And it was this, the outcome of that mandate, which was published on the 11th of May last month, which is then the revised guidance document for bees. Next slide, please. For a good environmental risk assessment, the definition of specific protection goals is key. And the setting of the value for the specific protection goal is a responsibility for risk managers. And that's why the discussions for the SPG were led by the Commission. We started in 2020 discussing with member states. I have to say at first that we started with discussing a protection goal for honeybees, and that was started with member states in 2020, but also 2 information sessions were held with stakeholders in January and November 2021. The discussions with member states were always, we always invited at least 1 risk assessor and 1 risk manager per member state to these meetings. But risk managers need to take an informed decision. And for that, to be able to do that, we needed scientific support from the EFSA. And the EFSA gave that to us in the form of technical reports. And for the discussion on the actual value of the specific protection goal for honeybees, this was based on a technical report by the EFSA regarding the analysis of background variability of honeybee colony sizes. And the discussion on the value was finalized in the council meeting, or the Agriculture and Fishery Council meeting of the 28th of June 2021. And during that meeting, a majority of EU agriculture ministers supported a new specific protection goal for honeybees of 10%. This value of 10% should be understood as the maximum permitted level of honeybee colony size reduction following pesticide exposure. And this value will be applied in the entire EU. It's a very ambitious value compared to what is currently still applicable, but also compared to the natural variability of colony sizes found by the EFSA. But, and that's very important, verification via field studies is still technically feasible, so it's possible in practice. Next slide, please. Once there was agreement on the specific protection goal for honeybees, we started discussing the similar goal for wild bees. And when I talk about wild bees, I mean solitary bees and bumblebees. Also here, risk managers needed to take an informed decision, and we received for that scientific support from the EFSA. And here the discussion was with an EFSA technical report regarding the analysis of the evidence to support the definition of SPGs for bumblebees and solitary bees. From that report, it was very evident that there is currently really an absence of sufficiently robust evidence to set an SPG for these bees. And that's why a majority of member states indicated for now to support, as long as there is not enough evidence, to support an undefined threshold approach for setting SPGs for both bumblebees and solitary bees. And so we informed EFSA to continue the update of the bee guidance document on the basis of such an undefined threshold. Next slide, please. But what does that mean in practice, such an undefined threshold? Well, so in practice, until further data becomes available, and in case of potential exposure of bees, then by default, we will require field studies for both bumblebees and solitary bees, unless the lower tier risk assessments for honeybees and non-target arthropods other than bees show no effect for the active substance, or semi-field studies with these bees show absence of effects. Furthermore, semi-field or field testing with bumblebees would also not be needed if acute laboratory studies with the OECD, according to the OECD agreed test guidelines, show an LD50 above 100 microgram active substance per bumblebee. Next slide, please. So, how will this revised bee guidance document now be endorsed? This is a two-step procedure which involves all member states in the Standing Committee Plants, Animal Food and Feed. And we actually already started the endorsement procedure in the last meeting, which was at the end of May, last month. The first step of these two steps is to check and, if needed, update the implementing regulations. And in particular, Commission Regulation number 546/2011, which regards uniform principles, which I always also call the decision-making criteria. And it's quite clear that this one will need an update, this regulation, because currently it still lists HQ values for honeybees of 50. With a specific protection goal agreed for honeybees, it's quite clear that an update of these values is needed in that regulation. Then there are also Commission Regulations 283 and 284/2013. These set out the data requirements for active substance and plant protection products respectively. For this one, we are analyzing to see if an update is needed, and if so, to what extent. So that is not decided yet, but we are looking into it. Once step one is completed and all is fine, only then the guidance document, the revised guidance document, can be endorsed in the Standing Committee. Next slide, please. At the same time, we are also working on the missing test guidelines. As you know, there are still quite some test protocols missing to test the effects of pesticides on bees. And so we are looking for concrete ways to support either development, validation and ring testing, or international agreement at the OECD. For that, we are currently, together with the member states, establishing an inventory of what is available. That's the easy part, but also what is under development currently or still needed to start to work for protocols to test the effects of pesticides on pollinators. With the publication of the guidance document, we are finalizing the inventory, and I hope to finalize it over summer. So after summer, we can move to the next step on the basis of that inventory, and that will be then a real work plan. Next slide, please. The latest news is always available 24/7 on the website of the European Commission. There you can read the whole narrative, how the SPGs were set, for example, with links to all relevant information, such as the supporting documents by the EFSA, but also reports of meetings we had with stakeholders and member states. The link is there for you to find all that information. Next slide, please. And that leaves me to thank you for your attention and to give the floor back to Mima. Thank you.
Thank you, Sophie. And also thank you for your clear presentation. That was, I think, it was a good example of dialogue between a risk assessor and risk manager, the setting of the SPG for bees. Okay, so I think we can move on to the next presentation that I will be given by me. So sorry, I didn't introduce myself at the beginning. I'm Domenica Auteri. I'm working in EFSA as a team leader of ecotoxicology team in the environment, plants environment and ecotoxicology unit. And I was the chair of the working group of for the revision of the bee guidance. Okay, next one, please. First of all, some background. With the guidance document, we had published a number of additional documents. So we have the main one is a supplementary information technical report where we can see all the detailed information beyond the guidance document and the analysis done and the data collected. Indeed, with this supplementary document, there are a number of annexes also published where we made available all data that have been used for the revision of the guidance document. The guidance document itself has also 3 appendixes. The Appendix A with the list of crop attractiveness. The parameters for content and dietary exposure is the Appendix B, and additional information for the metabolite risk assessment. But in addition to that, we have a free annex to this document. The Annex A is in common with the other guidance we had published early this year, the birds and mammals guidance document. And this for the refinement of residues dissipation. Then we have the Annex B that give recommendations for field studies to refine the exposure at a higher tier level, and the Annex C that gives a recommendation for higher tier effect studies. Next one, please. So overall, that's looking back and forth. We had we moved from a guidance of more or less 1 page, 300 pages in 2013, and now we had more than 1,600 pages, like 74 documents overall that have been published together with the guidance document. Next one, please. Okay, so let's start with the introduction. So in the chapter 1 of the guidance, you might see some introduction on the legal basis and also on an overview of the pathway of the exposure for bees. So we had considered that exposure might happen. The source of exposure is, of course, the use of the plant protection product, so according to the GAP table, and depending on the use, there might be emission in the environment which can contaminate different matrices, plant soil, or directly pollen and nectar when plants are in flower. But of course, some exposure might directly be happened to the bees, where they can be indeed oversprayed, or they can be in contact with residues in plants soils, but they also the main route of exposure is also the consumption of pollen and nectar. So we might have a direct exposure or an exposure through contaminated matrices. Where the bees can be exposed, we had to consider different scenarios, including the treated areas and the surroundings areas, as it was in the EFSA guidance 2013. Route of exposure in this guidance, we are considering the contact and the dietary as the main route of exposure. The type of effect is mortality. In relation to the contact exposure, and for the dietary exposure, we have mortality, brood developments, and sublethal effects. Time scale of the effect. For the contact, the working group has considered only acute as a time scale, while the dietary as acute and chronic for both adults and larvae, while the contact is only relevant for adults. Okay, so just to set the scene, because we had built the guidance having in mind this schema. So next one, please. So the scope of the guidance, this is chapter 2, we clarify that this guidance is in the context of the evaluation of plant protection products and their active substances under the regulation 1107. The focus is on direct effects, and so indirect effects are out of the scope of this guidance. And the focus is on chemicals. So the guidance does not cover microorganisms and semiochemicals. Semiochemicals, we refer here to all the substances that might be that belong to the definition of semiochemical, so even including the natural substances. And the focus is in technical mixture, which undergo the authorization under 1107. Next one, please. Okay, so in chapter 3, you may see the overview of the risk assessment process that we had developed. We had considered an exposure tier and an effect tier, and the two, of course, are linked together. So the exposure tier, we have three different tiers, so the screening, the tier 1 and the tier 2, for both contact exposure and dietary exposure. And the principle of the tiered approach is that screening is based on default value for all the parameters, and it should be very simple and not differentiation between scenarios. The tier 1 is still based on the default values, but it takes into account the differentiation between exposure scenarios. While the tier 2, it is based on measured data and number of possibility to refine the exposure and the parameters that are used in the models. So this is true for both contact exposure and dietary exposure. The effect tier, again, since they have to be linked, they are mirrored. So again, here we have a contact exposure and a dietary exposure. For the contact exposure, we have a tier 1, which is based on the standard toxicity endpoint and extrapolation factors for covering the untested bee species. And then we have a higher tier. The higher tier is it considers a number of semi-field, colony feeder, and field studies, which are distributed for honeybees and bumblebees and solitary bees according to the availability of those studies. Overall, we had identified 4 risk cases. So we have to for each, let's say, gap, we have to evaluate an acute contact risk, acute dietary risk, chronic dietary risk, and larval dietary risk. So these 4 risk cases have always to be addressed, both in terms of exposure and in terms of effect. And then you will see later on that how they are combined together. So next one, please. So in this chapter 3, you can also see the overview of the risk assessment scheme, where we start from the problem formulation. Then we, depending on the problem formulation, we move to the exposure assessment and the effect assessment. And then we move to the lower tier risk assessment. And if the risk can be excluded based on the lower tier risk assessment, we stop. Otherwise, we reiterate the process of recalculating the exposure assessment, first of all, until it is possible to refine the exposure, or otherwise considering if the risk is still not excluded, considering higher tier risk assessment. I want to mention that in addition to the standard risk assessment, we had considered two different methods, two different approaches that has to be taken into account, the lower tier, and that you will learn later on in the next sections. So one is the TRT assessment, and time resource toxicity is TRT assessment, and the other is for the sublethal effect. So next one, please. So just giving some more information on the problem formulation and the scope. So the scope is, so with this guidance, we had emphasized the definition of proper problem formulation in order that we can have a better consideration of the exposure for the different, also for different method of application. So the starting point is always the type of user and the user partner of the substance and the environmental properties. So looking at those, it is possible, first of all, to define whether these can be exposed or not. If there is no exposure, then we can conclude low risk. Otherwise, by doing this problem formulation, it is possible to identify the relevant exposure scenarios and also identify the relevant P exposure routes. Next one, please. So I want to mention that for the exposure scenarios, so first of all, with this guidance, we do not consider any longer the water scenarios. So as a, let's say, water as a contaminated matrix, because there was an in-depth analysis done by the working group, and overall there was a lack of data enabling us to put in place a scheme, and those data are related to the importance of this route of exposure, relevance in relation to also the specific protection goal, but also the frequency for bees for using water as a drinking water. We revised the crop attractiveness, as I mentioned. We revised the off-field scenarios, so the surrounding the treated area scenarios. We revised the weed abundance and the weed scenarios by taking into consideration the weed abundance, and also we revised the succeeding crop scenarios. Next one, please. Okay, so for the exposure, this will be explained later on, and also the effect will be explained later on, but in a nutshell, it is possible to identify the more suitable exposure model and identify the worst case predicted exposure quantity for each of the 4 risk cases. From the side of the hazard, it is possible to identify the hazard for the 3 B groups, and also identify the dose response curve for each of the 4 risk cases. Next one, please. Lower tier risk assessment. As I said, here there will be a combination of the 4 risk cases in order to get a predicted effect which might be directly comparable to the effect at the colony and the population level. This also will be explained in details later on. Next one. Okay, so additional specific considerations that have been made in this guidance. I already mentioned the time reinforced toxicity, which is in chapter 8. The new scheme for sublethal effect, which is available in chapter 9. New scheme for technical mixture, which is available in chapter 12, and a new scheme for metabolites, which is available on chapter 11. Next one. Okay, so chapter 10 is dedicated to the higher tier requirement, and here is where we have also the annex related to the exposure and the effect. We try to consider all the existing protocols as much as possible, and we identify the endpoints which are can be linked directly to the specific protection goal, and we had introduced a new statistical requirement. Next one, please. Okay, the other chapter that we have in the guidance is a risk mitigation measure. It's very, very short because risk mitigation measure belongs to more to risk manager. So we have an overall conclusion, chapter 14, which in relation to the term of reference, and the recommendation in chapter 15 for future research or development. Next one. The last, to conclude, we are developing a calculator. This calculator will be a web-based tool and will be available for the implementation of the guidance document. So thank you very much. We're happy to reply to your questions later on. But for the moment, I give the floor to Csaba for the presentation, for the next presentation. Please, Csaba, the floor is yours.
Thank you very much. So now we can go into some details. So many things had been mentioned already by Domenica, but in the next presentation, so you will see some further details. Yes. Okay, next, please. Okay, so about the exposure routes. So in this slide, you see two big blocks. So in the green one, you see the contact and the dietary. So these are considered the main exposure routes. These two always had been considered as the main exposure routes. Nevertheless, we all know that bees in the landscape, in the field, can be exposed other ways as well to pesticides. So here you see a list. Maybe it's even not comprehensive. The extrafloral nectar is resin, wax, honeydew, soil, mud, leaves. So it's not necessarily all for honeybees. The soil, mud, or leaves is more for other bees. Even the leaves can be for honeybees. So there is many other ways to be exposed. For those ones which are in the orange round, they are not covered by the guidance document. Why they are not covered by the guidance document? Not because the working group did not consider them as potentially relevant. They are potentially relevant, simply because there was not enough information and data to quantify those exposure routes. Therefore, no risk assessment scheme can be developed for those potential exposure routes. The working group believes that doing the risk assessment with the contact and the dietary, very likely we cover those other exposure routes. Nevertheless, since there is no quantification, this cannot be set for 100% sure. Therefore, we encourage the scientific community to make some research on those exposure routes. The water is in the middle of the two, so I put in purpose between the two groups the water. Why? Because as it had already been mentioned, the water, the contamination via drinking water had been considered in the 2013 guidance document, but removed no. Why they had been removed no? Because we had some data on the frequency of the water used by honeybees, and these data indicated that they use guttation water, for example, but also other sources of water very infrequently. This information in combination with the specific protection goal and the exposure assessment goal, it makes the water scenarios basically unlikely to be an issue. Once more data is available or the SPG became more stringent, the issue may come back. For the moment, the new guidance does not consider the water scenarios as relevant. Next, please. So we stay with the contact and the dietary as the main exposure routes. As it was mentioned already, the contact exposure is only an acute exposure. So the time dimension linked to the contact exposure is only acute. Yes, and this is therefore it is only during the flowering of the crop or the plant. So not necessarily the crop. If we consider the wheat scenario, for example, I will talk later on the scenarios or field margin scenario. If they are flowering, then the contact route is relevant. If they are not flowering, so the patch is not attractive, then there is no reason for the bees to go there. Therefore, there is no contact exposure. The dietary exposure, however, is relevant in acute and chronic terms. So bees can consume contaminated food item, pollen, nectar, even long term. And contaminated pollen nectar may exist even for pesticide application outside of the flowering period. For example, before the crop is sprayed before the flowering, through the plant, the pollen nectar may be contaminated, and the bees can be exposed when the crop is turns into flower. Okay, next, please. Okay, so this is about the application methods and the scenarios. In the first column of the table, you can see the relevant scenarios. What the guidance document consider: the treated crop itself, the weeds in the field, then two off-field scenarios, field margin adjacent crop, and the succeeding crop scenario. These 5 had been already considered in the 2013 guidance document. The ticks shows us which scenario is relevant for the 2 main exposure routes. So the succeeding crop scenario is not relevant for the contact exposure. Why? Because when we do the application, the pesticide application, the succeeding crop is not yet there, so it is not in flower. And as it was explained just before, there is no contact between the pesticide and the bees. The adjacent crop scenario is relevant, but it is covered by the field margin scenario. So that's why we see only 3 ticks in the contact column, but all the scenarios are relevant for the dietary exposure. The guidance document considers 3 main types of pesticide application, which covers most of the pesticide applications: the spray application, the seed treatment, so showing treated seeds, dressed seeds, and granule applications. Nevertheless, table 3 of the guidance document includes some information how to consider other type of pesticide applications. So we have 3 main application type, but there are some guidance also for other type of pesticide application, like drip irrigation or drenching and so on. Next slide, please. Yes. Okay, some changes regarding the scenarios from the 2013 guidance document. First of all, the off-field scenarios had been amended. In the 2013 guidance, we had only 2 scenarios there, one field margin and one for the adjacent crop. So in that small sketch, the B and the C. Now we have a new one, the E, or the field margin. So the new guidance includes 2 field margin scenarios and 1 adjacent crop scenarios. Which one used when, where, for which risk assessment, for which bees are explained in the relevant chapter. So don't worry about it. It's relatively simple to follow which one to use when. Then the weed scenario. In the 2013 guidance document, the weed scenario was considered as relevant by default, always for all crops, anytime. No, fortunately, we had some data. We had some data on the weed abundance of different crops, and the working group has digested this data. And what we learned, the main message from this data set, that in early crop stages of arable crops, so field crops, I'm not talking about orchards or vines, which is a separate story, only for field crops, early crop stages, weeds are not abundant. They are not really there. Therefore, the new guidance document now includes some tables explaining that in which crop and BBCH combination the weed scenario can be excluded at the problem formulation stage. The same database, however, included less data for later crop stages, indicated that, however, opposite of the previous later crop stages, weeds can be there. Weeds can be there. It's clear, and that's why I put the pictures there. And even in the last picture, if you have good eyes, you see a bee. So it's indeed there. This picture, I took this picture 3 days ago outside Parma. Okay, the field is a quasi-matured cereal field, so unlikely too much pesticide application we should not expect. Nevertheless, sure that weeds are there and bees are there. Okay, triggering succeeding crop scenario. Again, the succeeding crop scenario was in the 2013 guidance document by default always relevant. The working group now investigated the issue further, and based on some properties of the pesticide used, the application rate, the KUC, the DT50 in soil, so some physical properties, and also we have a toxicity trigger. So based on those combinations, now there are some guidance which explains the user when the succeeding crop scenario is unlikely to be relevant, and tables explain when at the problem formulation stage the relevance of this scenario can be excluded. Next one, please. Okay, so now I turn to some mathematical details, let's say. Next one, please. Details on the contact exposure. So this is how the description of the contact exposure looks like, the mathematical model. The aim is to calculate a PEC value, which is a predicted exposure quantity, microgram per B. It has only 3 parameters. The first 2 is not new, so the application rate is clear. The EF is the exposure factor. It had another name in the previous guidance document, but it does exactly the same. Maybe I quickly explain that the exposure factor is basically distinguish or differentiate between the scenarios. So the mathematical model is the same always for each scenario, but the EF value will get different values. It gets 1 for the treated crop scenario, which translates that 100% of the application rate is relevant for the treated crop scenario. But for the field margin scenario, for example, the EF is smaller. It takes into consideration the spray drift value, the spray drift percentage, and so on. The new factor here is the BSF, is the body surface factor. The body surface factor translates basically the application of the pesticide to B level. So it makes that the PEC is relevant for the bee, because it takes into consideration the surface of the bee. It's a new thing. It had not been like that in the old era when we used the HQ values. Basically, it was only the application rate. No, there is more focus on the bee. The bigger the bee, higher the surface, therefore higher the exposure. The smaller the bee is, the smaller the exposure. So it's very logical. Then, knowing and having a data set on bee size data, we can basically estimate the contact exposure for any type of bee. And fortunately, we found quite good data for a large number of bumblebees and solitary bees. So we had a distribution of data for the body weight and the body surface. And from that, the working group developed some factors which then make this calculation, this spec calculation, p-type specific. And what the guidance document proposed to take into consideration the 5th percentile small bumblebee as a default and the 5th percentile small solitary bee. With that, we can cover the whole group of bumblebees and solitary bees. Previously, I said that the bigger the bee is, the higher the exposure. So it can be a relevant question then why we consider a small bee, the 5th percentile bee is a small bee. You will see later on that something similar will happen at the hazard level when the 5th percentile bee will be taken into consideration. And when we do the risk assessment, so we combine the hazard and the exposure, then always the smaller the bee is, the higher the risk. So in that way, we are on the safe side, taking into consideration the 5th percentile bee. Next, please. Where we go to the dietary exposure models. So here you see much more complexity. First of all, it's not one equation, it's 3 sets of equations. So we have 3 types of dietary models: through soil contamination, pre-flowering contamination, during flowering contamination. The through soil contamination, here the process is that the plant, the crop or the plant, takes up the pesticide residues from the soil. That is modeled here. The pre-flowering contamination is when we spray onto the already emerged crop, which is not yet in flower. And then the during flowering contamination model is for the situation when the crop or the plant is already flowering. So obviously, you are not expected to learn immediately those equations. It's rather complex. In later slides, I will have some visualization and explain what these equations do in a more digestible manner. Next, please. Okay, this is just to show you that the 3 mathematical models use a lot of parameters. So I wrote there 19 parameters, but the 19 parameters is just the starting parameters, which all has a default value for the tier 1 risk assessment. But from the 19 parameters, we make other parameters. So actually, there are more than 19. Next, please. Okay, this slide explains the relevance of the dietary model. So we have 5 scenarios. These are the columns. But which mathematical model to be used for which scenario when, and the when means the first column of the table. So when the pesticide is used in terms of the crop development, BBCH is the crop development stage. So depending on that, we use the guidance document recommends to use different mathematical models. Let me start at the end of the table on the right side, because it's simpler. So let's take first the succeeding crop, super simply. For a succeeding crop, one type of mathematical model has to be used always. Doesn't matter when the pesticide is used. The pesticide anyway used in the previous for the previous crop, not the succeeding crop. So this is the through soil contamination logically, because the succeeding crop can be contaminated from the pesticide used in the first crop, maybe the first year even, only through the soil. Then the adjacent crop and the field margin, again, one type of mathematical model can only be used, the during flowering contamination. This is because the default assumption, whenever use the pesticide, the field margin and adjacent crop is in flower. So that's why the during flowering contamination model has to be used. For weeds, we have two options, the through soil contamination or the default, the during flowering contamination. This later on again obviously assumes that the flowers are, if they are there, they are in, so the weeds, if the weeds are there, they are in flower. The through soil contamination can only be used if it is guaranteed, if we know for sure that the pesticide application happens on totally bare soil situation. So nothing is emerged, no crop, no weeds. There are always, for field crops, there are always a few days at least, maybe a week for this situation after the seed bed preparation, for example. Okay, for the treated crop, this is the most complex. All the three can be used depending on when we use the pesticide on that crop. So before emergence, which is BBCH less than 10, the through soil contamination. After from the emergence till the beginning of the flowering is the pre-flowering contamination model, and during the flowering, obviously, the during flowering contamination model has to be used. And after flowering, basically it is considered there is no exposure. Next one, please. Okay, now the details are coming. So again, I start at the end. This gives some visualization how the mathematical model for the during flowering model is working. So you see in the left side the parameters which had been considered, and you see that from some of the parameters we calculate another value, which is here called PRUC, which is an error. So we sorry for that. It's a mistake. It should be PCUD, stands for predicted concentration per unit dose. So this is a concentration, is a predicted concentration. If you look at, it is calculated from the RUD values, which are default set of pesticide residue levels in pollen and nectar, taking into consideration some other parameters. So from these parameters, combining them, we get an estimation for the concentration, which is relevant already for the pesticide use in terms of number of how so multiple applications basically already taken into consideration here. We have separate for pollen and another one for nectar. Then this predicted concentration will be combined with the food consumption data of the bees, how much they eat from the pollen or the nectar. So the combination of the concentration and the food consumption, we get a value which is called SV shortcut value. The shortcut value is not new. We already used the shortcut values in the 2013 guidance document. They are derived in the same way with Monte Carlo analysis. And then you see 3 risk cases there. So a separate shortcut value will be calculated for the acute adult risk case, for the chronic adult risk case, and the larva. Why? Because the food consumption is different for each cases. Also, different shortcut values exist for honeybee, bumblebee, solitary bee. So finally it became a big table. The tables, so the shortcut values are already calculated for tier 1 because everything is relying on default values. But many of them can be refined for so-called tier 2 calculations. So in the column in the first block, you see when it is indicated tier 1 or tier 2. When tier 2 is indicated, it means that either the default value is used, tier 1, or if active substance gap specific data is available, then the parameter can be refined. So we arrive to the shortcut values. We have two shortcut values. We have many shortcut values, sorry, because of the many risk cases, but we have a set of shortcut values for the pollen and a set of shortcut values for the nectar. Combined these two with some other parameters at the top of the list, the application rate and the EF, we get finally the PEC. Okay, for the free risk cases, the next one, please. Yeah, here you see something very similar for the pre-flowering application. For the pre-flowering application, so I will not explain, it's very similar. Some parameters are different here. We have a new PFF, I will explain later on, and we lack another one. Next one, please. This is for the soil. It's simpler. We have less parameters, but the logic of the derivation is the same. Then I should mention that at the end of the day, we can a PEC value for the through soil, a PEC value for the pre-flowering situation and during flowering situation. But of course, if there is no pesticide application in one or the other time, then they will be 0. So at the end, we add together all the three. One or the other can be 0 if there is no application. And then this will the final PEC value, which will go to the risk assessment later on. We have to do this for all the scenarios. Of course, what goes further to the risk assessment is the one which is the highest PEC among all of them. Next one, please. A few words about the very new parameters. So just 3 of them I would like to mention: the LF, the landscape factor. Here in the small chart, you see some data. You see the data which led to the LF. You see that basically, so what is LF? Is the landscape use by the bees. So how much they use the treated crop, the contaminated treated crop, how much they use alternative food sources. So these are pollen data, honeybee collected pollen from oilseed rape fields. It's basically span from 0 to 100. All these data, with some worst case assumption, had been used for the shortcut value calculations. Then the PEC per water is relevant for the through soil mathematical model. The concept itself had already been included in the 2013 guidance document, but it was not an explicit parameter for tier 1. And then the other one is the PFF. We have the PFF because we have default pesticide residue levels, RUD values, only for during flowering applications. So that's why the two orange column for the two situations before flowering, during flowering, are the same. Because we have only one type of RUDs during the flowering, and this is used also for pre-flowering applications. The PFF makes the use of these RUD values more realistic. The main parameter which is taken into consideration, the PFF, is the process within the crop. So we spray the crop, there are a dilution, there are a dissipation, and this has been taken into consideration for the PFF. Next one, please. Refinement options very quickly. Next one, please. So I mentioned that some parameters can be refined in Tier 2 assessment. This is the EF parameter for both dietary and contact. This is only for certain crop situations, which is described in the guidance document, or the PEC contact itself can be refined with targeted field studies when the chemical bees have to be captured after the application, and the chemical can be washed off from the surface of the bee to get a more realistic PEC parameter. Next one, please. This is the list of the parameters which can be refined for the dietary exposure. So the pore water, again the EF, the residue levels in pollen and nectar in field studies. My last slide, which is the next one, will be about that. Of course, the residue decline in pollen and nectar also can be refined. The landscape factor also can be refined in appropriate and suitable field studies. And the sugar content, which I forgot to mention, the sugar content is also taken into sugar content of the nectar is also taken into consideration for calculating the oral exposure via nectar consumption. And then my last slide, please. Yes. So exposure field studies. So this is basically the refinement of the residue values for pollen and nectar in appropriate field studies. So the aim is to benchmarking the residue levels in pollen and nectar in field conditions. The aim is to have a data set which encompass the 19th percentile worst case residue level in pollen and nectar. This is the EXEG, so the exposure assessment goal, the 19th percentile exposure situation in field conditions. In the graph, in the right side, you see basically sampling methods which are from the reality, from the real world. So we learned it from people are doing this type of studies to take pollen nectar samples and then subject it to residue analysis. So in the black box, you see basically 4 different sampling methods. Either the pollen and nectar sample taken from flowers, either semi-field or field, or it can be taken by bees, from bees, so in front of the hive, in semi-field conditions. They consider, so the top level is considered as a kind of worst case type of sampling. Then the guidance document recommends or offers another solution, which is the blue box in the middle, minimum alternative for each field. So this is an open field situation, but then the laboratory or who conducts the test, the tester has to ensure that this landscape offers only very minimal alternative food. In this situation, 5 fields has to be, at least 5 different fields has to be tested. Then the alternative solution is at the bottom in the orange, the so-called randomly selected landscape field situation. When this requirement is eased, so the landscape can contain some alternative foods, but then the number of fields has to be at least minimum. And that was my last slide. So thank you very much. I give the floor back to Domenica.
Thank you, Csaba. So we have been very efficient in these first sessions and start the Q&A. We can take 10:30, so we have 30 minutes for answering your questions. I give the floor first to Sophie, who will take the questions related to her presentation first. The floor is yours, Sophie.
Thank you, Mima, and you can see me now. Okay, first I will take a question which was sent in prior to this information session, and I actually combined several similar questions to one. And this is, when will the bee guidance document be noted or endorsed? And from what date will it be applicable? Will it be a phased implementation again with the honeybees first and the wild bees later? So that was already sent in before this information session. So, like I explained earlier in my presentation, the endorsement procedure requires two steps. The first step is to check and, if needed, amend the implementing regulations on the uniform principles and the data requirements. This will take some time as it needs to be prepared, consulted in the Commission, discussed with the Member States in the Standing Committee, and also consulted with stakeholders publicly via a feedback mechanism. Therefore, with all these procedures, a vote in the Standing Committee is only possible at the earliest in the last quarter of this year. If then the draft regulations receive a qualified majority of the votes from the Member States, it is then sent to the European Parliament and the Council for scrutiny. And that scrutiny phase takes an additional 3 months, during which the European Parliament and the Council can object the acts. Only when green light is received from the Parliament and the Council after that scrutiny period, then only then step 2 of the endorsement procedure can take place. And that will be at the earliest in spring next year. Currently, a full implementation is envisaged, but the part on wild bees will be, wild bees, I mean solitary bees and bumblebees, will be implemented in line with the agreed specific protection goal, which means by default field studies will be required unless certain criteria are met. Please note, as stated in Chapter 7.3 of the guidance document, that based on an undefined threshold, a lower tier risk assessment scheme, as is also available in the guidance document, cannot be implemented since there are no values which would allow interpretation of any quantitative lower tier outcome. And one of the points to be discussed with Member States is indeed the date of application of the updated guidance. So I cannot give you a date right now. It will be discussed with Member States, and this will also be influenced by, for example, the seasonality of being able to do field studies. And then I will move to the questions received during the session. What data is there to support the 10% protection goal? Well, I mentioned the supporting documents prepared by EFSA, this technical report, so you can find it in there. They are available online on the EFSA website, and also the link is also included on the Commission website, which I mentioned during my presentation. Then another question which came is on the requirements for not needing bumblebee and solitary bee higher tier studies, honeybees and NTAs. Did I mean no effect or passing of the lower tier risk assessment for honeybees and NTAs? I mentioned no effect. Well, the exact wording of that will be fine-tuned when we discuss with the Member States the amendment of the update of Regulation 546/2011 on the uniform principles. And I will ensure that there is a harmonized interpretation so that everyone understands it in the same way. So you can be sure that once there is a draft in the comatology register, that this will be very clear. And then there were two questions which I now take together. Is there a target date for endorsing the new B guidance document? Are any transitional periods foreseen for implementing this guidance and the risk assessment method that it describes? As I said earlier, with answering the first question, a target date for endorsing, not really, as soon as possible, respecting all the procedures I described. So spring next year will be the earliest possible. And then the transitional periods will be discussed with member states, and we will take all relevant factors into account. Voila, these were the questions I wanted to answer, and I pass the floor to Mima. Thank you.
Thank you, Sophie. Thank you. Okay, so now I can answer to some of the questions received related to the presentation, to the overview. So first of all, on the scope of the guidance, I already mentioned that microorganism and semiochemical, including natural substances, out of the scope. And because, as you have seen, default value have been, let's say, built on residues for chemicals. So the working group has considered not suitable the use of the tier 1 for those type of substances, and for which a dedicated guidance is needed, particularly for the microorganisms. Also, the data requirements are now new ones. So further action should be taken. The second question that was received during the registration: how to select worst case approach in case of complex and multiple applications, so before, during, and after the flowering. Well, the problem formulation will indeed help identifying all the cases, identifying the relevant scenarios, and identify also the proper model. Of course, when there are multiple applications which would cover different PBCH, all the relevant models should be used to calculate the predicted exposure quantity. But in the end, the worst case will be selected. The calculator, and here I move to the question related to the calculator, would actually support the calculation of the predicted exposure quantity and the selection of all the relevant scenarios and models. Indeed, for the calculator, there were a number of questions on when will be available, and we cannot at the moment give detailed timelines. So we are working, and the calculator was started, the development was started before issue the guidance, but considering the changes that have been done following the public consultation, we need some time. So of course, the plan is to test it. So similarly as we did for the birds and mammals guidance, we might organize testing with stakeholders and member states, and we can also organize an info session in order that at the time of the implementation of the guidance, we have a calculator which fully works and was already tested, and stakeholders have been informed. The calculator will be hosted by the R4EU platform, and is a web-based tool, so there will be no storing of data, so there is no issue of confidentiality. So the other question I got, okay, I already answered regarding the possibility to apply the guidance to microbial pesticide. I would say no, because I would repeat that it is not recommended, because the guidance is built on the let's say default values based for suitable for chemicals. Other questions, working examples. So many of you have been asked during the registration whether it is possible to have a working example. I think this is what we will do when we enter into the testing phase of the calculator, because this, at least for the tier 1 and the tier 2, which is the refinement of the exposure that are included in the calculator, and a number of other parts that are included in the calculator. A different story will be for the higher tier test for the field studies, and specifically for the new statistical requirement, where probably we need to organize something dedicated. Okay, so I think I can pass the floor now to Csaba for your questions related to your presentation. So thank you, Csaba. Floor is yours.
Thank you. So I think I have some time, so I will take some questions. Before the meeting, there were a question about the pollen nectar DT50s, what we use. So where lies the difference between choosing DT50 of 3 days for pollen and 2 days for nectar? So the values themselves were not mentioned in the presentation, but right, the DT50, so that the decline of the chemical in pollen is set as 3 days, and for the nectar is 2 days. So I just suggest that check the data set behind this choice in the supporting document of the guidance document, where everything is very transparently written, and all the data are given. If you go there, you will see that there are some differences indeed in the data for DT50 for pollen and nectar, not huge differences. So the question is right. There is no huge difference between pollen and nectar. The average is below 1 day, just mentioned. So we more talking about, more attention was paid on the extreme values, on the higher values, and it tends to be that pollen, the chemical can resist in the pollen a little bit longer, in generally speaking, than in nectar. Then another question: can the guidance Sante 2019 12752 to be used to support extrapolation of residue data? So this Sante guidance is about the MRLs, so the maximum residue levels, which is for foodstuff. And the answer is no. This guidance is not suitable for this purpose, to do ecotoxicology for bees via absolutely other type of matrices like pollen and nectar. Okay, then there I got some questions during the event. So the first one: why only the worst case spec scenario is considered in the risk assessment and not a combination of all the scenarios? In the field, there could be an exposure via soil and pre-flowering application, for example. Okay, so the requester is asking why we do not combine, if I understand well, why we do not combine the 5 scenarios. So we should consider that we have only, the application is one, can be multiple application, but still the mass of the active substance, the pesticide, what we put out is 100%, let's say, and we calculate a pack for all the scenarios. One of them is the maximum. If we start to combine them, we may go more than 100%, which would be a wrong thing. Also, please consider that the exposure in the different scenarios may happen different times, absolutely different times. So if we do a pre-flowering application, exactly what the example says, then the exposure through the plant, the crop itself, will happen later, but for field margin it's immediate. So it's this combination would not be like to like. Then Does the new guidance reflect and allow on novel approaches like spot applications, drift, or spill reduction techniques, drone applications? This will significantly reduce exposure on field from now, and therefore is indeed a refinement for exposure. Okay, so I suggest to consult table 3 of the guidance document, which gives some tips for some particular non-standard or more rare application techniques. However, brand new techniques like drone applications are not there. This is a new topic, and we will go further on. It's right. Maybe they significantly reduce the exposure, but the guidance is not yet prepared for these brand new techniques. Then, in through soil contamination are taken into account. So in through soil contamination are taken into account data regarding the metabolism of the active ingredient in plants, usually submitted when dealing with residue section of the dossier of the active ingredient. If the metabolism data show that the substance does not move from roots to leaves, flowers, the exposure should be considered negligible. Yeah, the statement behind the question is right. If it is absolutely proven that it does not move, then indeed the exposure is obviously less or even negligible. But the data in the metabolism, that the standard metabolism studies is not necessarily sufficient to robustly demonstrate this. If this has to be demonstrated, it is more proposed to do a proper tier 2 risk assessment with residue measurements. Yeah, the residue measurements from pollen and nectar immediately cover all the processes. Then the table of scenarios to be used, I do not understand completely. For BBCH less than 10, the scenarios for adjacent field and succeeding crop need to be assessed always. The answer is yes. So the BBCH stage is for the crop, the treated crop scenario. So when the pesticide is used compared to the crop development. So in this case, in this example, the crop itself is not yet emerged. It may be seeded, but not yet emerged. But what we assume with the adjacent crop scenario, field margin scenario, that next to this field, which can be a bare soil, next to this field, there is a flowering field margin on adjacent crop. And also that later on the season, so this crop is grown, it is harvested, and after that, in the next season, there is another crop from where the residues may be taken up. Okay, is the succeeding crop exposure scenario only relevant for systemic pesticides, as the exposure is only via through soil contamination of the succeeding crop and the bee being exposed to the crop plant? For the succeeding crop plant, yes. But I would like to mention that the guidance does not use the expression of systemic pesticides. What is systemic pesticides is actually not defined. Okay, so it's not quantified. There is no quantified definition. It is used, commonly used. We understand what does it mean, but actually for a certain pesticide, if it's called systemic or non-systemic, we cannot guarantee that they do not move in the plant, even if it is considered as systemic. Okay, I don't know how much I can go further, but I think there are some more time. So why are weeds not included in the seed treatment in the dietary exposure? Yes, indeed, there was a footnote in that table. So this is coming from the 2013 guidance document, where it was already considered there. So please consult the old guidance where it is clearly described. Then let me just look at the agenda, because I don't want to go over the time.
No, Csaba, don't worry. Go on. We still have 6 minutes.
Okay. Okay, so then I take this one. For pre-flowering applications, the shortcut value are higher compared to the during flowering applications. Very good observation. I did not speak enough from the pre-flowering application, so I'm happy with that question. So as long as there is no PFF that can be used, the pre-flowering application are worst case compared to the during flowering. How should this be addressed in the risk assessment? Can the shortcut value for during flowering be used for pre-flowering applications until the PFF is applicable? No, we really distinguish shortcut values for pre-flowering and during flowering. But if you consult the table with the small table with the concrete pre-FF factors, it says in the first column that if the pesticide application compared to the start of the flowering is, so the time period between the last application and the start of the flowering is less than 15 days, then yes, then basically this scenario should be considered as it was during flowering. That's what our guidance says. If this time is more, then the exposure from pre-flowering application will be lower compared to the during flowering application. Here I take the opportunity to say something what I forget to say, and it's important here that to use the PFF, we need to know the time between the last application and start of the flowering. This is a kind of difficulty with the PFF, because the pesticide application are normally linked to the BBCH and not the calendar day. So it is not expressed in number of days or whether it is April, May, or whatever. It is the BBCH stage. But to use the PFF, we indeed need to know this number of days between the last application and the start of the flowering, which then has to be assessed case by case. So there should be a proposal, and only after the PFF can be used. Okay, so I go further. I wonder why the chronic contact through multiple application, for example, weekly or biweekly applied fungicide, is not considered. So why the chronic exposure route is only acute, basically, and why not multiple application is taken into consideration? This is simply because if you think that we have weekly or biweekly application of the same pesticides, then the probability that the same bee, because we are talking about individuals here, the overall exposure is on the individual. So the same bee visit the same field, which is sprayed at the same pesticides again and again, and always, and she visits always in the wrong moment. So we consider that the contact exposure is very short. So it's either we overspray the bee, or the bee is contaminated to the surface, which is freshly sprayed. So it's still wet, which is a very short time. So the probability that the same bee exposed multiple times is very, very low. So that is the reason. Two more. For the wheat scenario, two models can be used, yes, but this does not cover wheats that have emerged but are not in flower. Which model should be used for this scenario? So I have to digest. For wheat scenario, two models can be used, but this does not cover wheats that have emerged but not in flower. Yes, basically, as soon as the weeds are there, we consider that they are in flower. This is a simply worst case assumption. It would have been very complicated. Right, the scenario can happen a few days, but it would have been very complicated to take into consideration this as well. There were some thinking, I can tell you, but finally we could not address this scenario. The last one, is the guidance considering multiple application? Yes, simply yes. If you look at the mathematical models, the number of applications is absolutely included in this PCUD. It should have been PCUD, predicted concentration model. Thank you very much. So I finished with my question. I give it back to Mimma.
Okay. Thank you, Csaba. Perfectly in time. So I think we can start the second session. In this second session, we will have 3 presentations, one on the lower tier, and the second on the lower tier hazard, the lower tier risk assessment. Both will be given by Alessio. And then we will have Alessio Ippolito, and then we will have a third presentation on the time-reinforced toxicity that will be given by Brett Ingles. So I would propose to start with the first one, and I give the floor to you, Alessio.
Thank you, Mimma. Thank you for the introduction.
Just one minute for allowing the sharing of the second block.
Yes.
Presentation. So we might have a technical problem. Sorry, we don't see them.
I think they are coming. So let's give it another. Yes, perfect. Thank you.
Yeah.
So
okay, the system is quite slow, but probably because we have a very huge number of attendees. So back to you, Alessio.
Thank you, Mimma. Yes, indeed. So this block of presentation will deal with chapter 6, 7, and 8 of the guidance document. And as you said, I'm going to be presenting 6 and 7, and then chapter 8 will be done by Brecht. Next slide, please. So we start with chapter 6, which is effect assessment in lower tiers. I have immediately to say that there are a number of novelties which have been introduced with concerning effect assessment in the lower tiers. I had to make a selection of those because the time was not really sufficient to go through all of that, but I hope that I will be touching on the most important things. Next slide, please. So the first one, which I believe is quite important to mention, is that the new guidance document stopped relying on point estimates for hazard characterization. When I say point estimate, I mean LD50, LDD50, and OED. And instead, the newly supported hazard characterization is in fact constituted by the full dose response. This makes use of more information from the laboratory tests, and most importantly, avoids using inaccurate assumption, such as assuming a linear dose response as it was done in the past. So I just want to draw your attention on the plot that you see on the slide on the right. You have 2 dose responses for 2 different substances, which are called substance A and substance B. The LD50 or the LDD50 of these 2 substances is exactly the same. So in the past, we would have considered these 2 chemicals to be exactly equivalent from the hazard perspective. In reality, if you take a look at the dose response, you will see that they're only equivalent in 1 point, so at the dose of the LD50. At every other exposure level, they will produce a different outcome in terms of effects. So take, for example, the exposure level which is marked by the arrow, and you will see that substance A will be producing something around 15% effect, and the other substance will be producing practically no effect. So it is very important to consider that. And I also would like to make advantage of this picture to highlight another important aspect which is going to be useful in a while. And that is that once you fix the point common between 2 curves, in this case it's the LD50, when you have a shallower dose response, which is the case for substance A, then any dose, any exposure level, which is below the fixed point, so the LD50, will be producing a higher effect compared to a steeper one. The opposite is true for exposure levels that are above, let's say, the fixed point, so the LD50. Now, I have to say, for sake of standardization, the guidance document recommends selecting among 4 dose response models, which are the ones included as a family 1A for quantum responses in the newly published EFSA BMD guidance document. And these are the Hill, which is very often called also log logistic model, log normal, exponential, and inverse exponential. Since we are only dealing with survival-like data, basically these models are all described by 2 parameters, one of which determines the inflection point of the curve, and the other one is proportional to the slope. We may have a 3rd parameter in the case there is some mortality in the control, and that sets basically the baseline of the curve. Next slide, please. So another very important topic that I would like to spend some time on is the interpretation of the legal requirement. So obviously the starting point for us was the regulation 283/2013 for what concerned the active substance. And there it is requested that if exposure cannot be ruled out, then the standard testing to be performed is acute oral and contact toxicity to bees, chronic toxicity to bees, and only bee brood toxicity testing. We've interpreted this requirement as to say that in principle, every dossier should contain experimental tests for all bee groups, obviously depending on the use of the problem formulation. However, as a general rule, tests should be performed according to standard guidelines, and we know that we only have standardized guideline, OECD guideline for honeybees and for acute testing of bumblebees. That shouldn't stop applicants to also use other existing protocols to complement the data package and to use existing literature data if they are available. But the way we tackle this is that within this guidance document, we also propose a methodology for extrapolating from honeybees to other bee groups. And I will be touching more in detail about that in a few slides. When it comes to plant protection products, the reference regulation is, of course, 284/2013, and then they say it's clearly said the toxicity of PPP cannot be reliably predicted from the active substance, then studies with the PPP are required. And we interpreted this by making a distinction between formulation with more than one active substance and formulation with only one active substance. So all of that is summarized in the table that you see in the slide. So basically for active substance, the tests are required for the 4 risk cases always. For the formulation, it depends. So if you have a formulation with more than one active substance, then experimental testing is required for the 4 risk cases. In the case where the formulation has only one active substance, the first step is to produce testing in terms of acute testing. And then if these are produced and there is an indication that the formulation is more toxic than the active, and this comparison is performed by means of comparing the LD50, and if there is the LD50 for the PPP is lower by a factor of 3 compared to the active substance, then the PPP is considered to be more toxic, and therefore also chronic and larvae tests should be provided with the PPP. A further caveat here is that in the study with the active substance, in some instances, especially for difficult substance to test, it may be acceptable to get also tests performed with a formulation to cover for the active substance. Next slide, please. So another important element of novelty in the current proposed risk assessment is the concept of the surrogate dose response. So often we are in the case that, especially for substances of low toxicity and difficult substances, it's difficult to get in the test and effects that are high enough for describing given a partial dose response. So in that case, the guidance document proposed to derive a surrogate dose response, which is based on conservative assumptions. The cases where a surrogate dose response are clearly needed is in case of limit tests. So whenever you have a test which is performed on only one dose. Obviously, you cannot derive a dose response for one dose only, but we can derive a surrogate dose response also in those cases. And also situation where the tests are performed as normal dose response, but the maximum observed effect in terms of corrected mortality. We've received questions also before the session concerning should effect be considered corrected mortality. Yes, corrected mortality is the one that matters. If the effect is below 10%, we cannot even describe even a partial dose response, and therefore in that case surrogate dose response is needed as well. Obviously, when you don't have experimental data to fit a model, whatever model you select is completely arbitrary. And we decided that, well, we proposing as a methodology to rely on the log logistic model. Is one of the most common model, and it has a very straightforward interpretation of the parameter, because there's only two parameters. In fact, one is equivalent to the LD50, and the other one is the parameter, let's say, proportional to the slope. So the surrogate dose response can be constructed in a very easy way. For what concerns the slope, we will be proposing to use a default value. This default value was obtained by taking the 10th percentile of the slope distribution from about 300 studies with 81 different substances, and this value is 1.43. And remember that we said at the beginning in the previous slide that assuming a shallower dose response, so with a smaller slope parameter value, represents the worst case for everything which is below a fixed point. And the LD50 is again, it can be extrapolated simply by considering the distance between a certain level of effect observed in the test and the 50% effect. And this is obtained with a default slope of 1.43. So the extrapolation factor to the LD50 are the ones that you see in the table. And I just wanted to provide you with a couple of examples to illustrate, let's say, the concept. Let's say we have a limit test. The only tested dose is 30 microgram per B per day, so it's a chronic test. Mortality in the control is 7%. Mortality in the treatment is 18%. So the corrected mortality is 11.8%. That means we're following the second bracket, let's say, of the table. So the extrapolated LD50 is simply the multiplication of the only tested dose times the appropriate extrapolation factor, which is in this case 2.6. And the slope is the default default value of 1.43. Pretty much the same that you can do with the dose response test, which is resulting in the highest corrected mortality of 8.8%. So we can really describe even a partial dose response up to 10%. And it works exactly the same way, except in this case, obviously, we're going to be using the extrapolation factor that is in the first bracket of the table that you see above, so 4.6. Next slide, please. So we're gonna. I just want to consider again the last example I've been making for highlighting a couple of things. So you see in the plot on the right, you see the gray dots are the experimental values. The greenish line is the the surrogate dose response as defined by the methodology. And as you can see, the methodology ensures that at least 90% of the time, according to our estimation, the effects of the doses below the one resulting in the highest effect are conservative. But I also want to draw your attention on the reddish line. That reddish line, even if it's not fully explicit from the 2013 guidance document, it will be the linear dose response that it would have been applied in this case. When you're applying trigger values, in fact, in this case, the endpoint was an LD50 above 40 microgram per B, but that above is not really considered in the calculation of the TERs. So that red line is the one that would have been used implicitly when estimating the risk. And as you can see now, the new methodology ensures that is a worst case, but it's not as overly conservative as it was in the previous guidance document. Next slide, please. So another element of novelty is the explicit consideration of the time course of the effects. We know that the exposure time can play very different roles in the expression of the maximum effect. And we've recognized at least two most extreme cases. One is the time-reinforced toxicity that Brett is going to be talking about later on. And this happens when exposure time matters even more than the dose. The opposite end of the spectrum is what we've called fast expression of the effect. Perhaps it was not the best naming that we've given, but anyway, what it means is that this exposure time has limited influence and the effects are mainly driven by the dose. So in this second case, the difference in the effects triggered by acute and chronic exposure is in fact negligible. And what we're proposing is that in this case, we take the acute exposure as the only one that matters, which is worst case in terms of estimated exposure level. And we combine that with the chronic dose response curve. So we're basically merging two risk cases into one by taking the worst case on both sides. And this is, so how do we do that in practice? In practice, that's quite easy, in fact. How to discern, how to discriminate when we have this fast expression of effects. We just consider the LDD50 in chronic test at 2 and 10 days, and we are proposing to do that after fitting the data to the GUTS modeling. But again, Brecht is going to be talking more about that in the TRT presentation. By the way, if TRT is demonstrated or not disproven, there is no further consideration of fast expression of effect. You can have both two at the same time, so it's either or. So if the substance is clearly not presenting TRT, we can follow on with the evaluation of a fast expression of effect, and by comparing these LDD50 at 2 and 10 days. If there is significant difference between these two, or the median values of LDD50 are separated by a factor of 3, we follow on with the standard assessment. If they are not significantly different and the median LDD50 are within a factor of 3, then we conclude that there is, in fact, fast expression of effects, and we follow with the approach that I've just illustrated before. Next slide, please. So this is the last slide of this presentation about hazard, any concern about extrapolation between species. So we know already that experimental data for bumblebees and solitary bees are unlikely to cover all risk cases, and most importantly, the diversity of bee sensitivity within each group. So we derived the simple extrapolation rule, which accounts for the significant empirical relationship we found between the LD50 and bee weight, something similar to what was done for the exposure, in fact. The declared goal of this extrapolation is the derivation of those responses which are protective for 95% of bee species by taking as a reference, in fact, the 5th percentile in bee weight distribution, as it was done for the exposure. And this is done within each group with 95% of confidence. On a practical level, that means that the dose response is just the empirical dose response obtained for the standard species shifted to the left, so to lower doses or lower exposure level, by the appropriate toxicity extrapolation factor, which is abbreviated in TEF. I should mention that TEF were empirically derived from acute toxicity tests, because the acute contact toxicity test, because those were the only ones that we had enough data to work on. But they are equally, the same TEF are equally proposed also for the risk cases, except for larvae, and I will get there in a moment. Whenever bumblebees and solitary bees experimental data are available, likely with standard species, they should be used as a basis for the extrapolation within their groups. And the extrapolation factor are summarized in this table in the slide. I just want to draw your attention on the fact that for honeybee, for extrapolating from honeybee larvae to bumblebee and solitary bee larvae, we are choosing a factor of 1. And this is because in reality, in this case, we're not the exposure levels is not estimated on the 5th percentile bumblebee or solitary bee weight, because we couldn't really establish that relationship for larvae. So the exposure is in fact related to Bombus terrestris and Osmia species, which are either heavier or anyway comparable weight as honeybees. So we felt that it was fair not to add, again, more conservatism, and we're just taking a factor of 1 for extrapolating, let's say, the hazard part for larvae from honeybees to other bee groups. Next slide, please. And I think, in fact, with the next slide, we start the new chapter, chapter 7, which is about the lower tier risk assessment. Next slide, please. So we start with honeybees because this is the one that is actually well implemented, for which the implementation is, let's say, ready to use. The conceptual process underpinning each lower tier assessment for honeybees is composed, in fact, of 3 steps. The first one is to estimate the effects at the individual level for each risk case, then to upscale the effect from the individual level to colony level for each risk case, and finally combining all the effects of the different risk cases in one single estimate of the effect of the colony level. Next slide, please. And we're going to be starting with step 1, which is perhaps the most straightforward. Obviously, this is the part where the exposure estimation and the hazard characterization gets, let's say, combined. As Csaba has presented before, the outcome of any exposure assessment is a predicted environmental quantity for each risk case J, which is a worst case across scenarios expressed in the same unit as the dose of the toxicity testing. It could either come from any exposure tier, so it could come from the screening tier 1 or tier 2. Just keep in mind that the screening tier is not really allowed in case the TRT is not excluded. The hazard is, of course, defined by the dose response curve, which in fact links the predicted exposure to the predicted effect on the individual level. So let's take the example of the figure in this slide. If you have a predicted environmental quantity of 1 microgram per B, and then when we relate that to the dose response curve, we obtain a predicted effect at the individual level of 20%. In the case of one thing that I need to be mentioning here is that in the case of the TRT properties, the 10-day standard chronic estimation for both exposure and the dose response will be substituted by a lifespan 27-day exposure and dose response curve. But Brecht is going to be talking a bit more about that later. Just for, let's say, pointing out that this is the point in the risk assessment where you should be considering presence of TRT. Next slide, please. Which is concerning step 2. So we know that the specific protection goal for bees, in the specific protection goal for bees, the entity to be protected is either the colony or the population. And for honeybees is obviously the colony. So any effect on the individual level need to be upscaled at the colony level. And in order to find a relationship which was able to cover all possible situations, we had to select a reasonable worst case assumption. And this assumption was made on the fact that basically colonies do not have any buffer capacity. Obviously, this is mostly not true, but in some cases it might be true. So we take that as a reference. That means in practical that the effect at the individual level in terms of percentage mortality of the exposed bees is translated directly into an effect at the higher level as a percentage reduction of colony strength. So let me be very clear. If you have a 20% predicted effect at the individual level, that is translated into a 20% reduction of the colony strength. The conservativeness of this assumption was further checked by a behave simulation by assuming that either all foraging would be experiencing higher mortality or all adults in the colony or all for 210 days. And we've basically confirmed that this assumption is in fact is conservative enough for a tier 1. Next slide, please. The step 3 is the combination of the effects of the colony level. This is another big element of novelty. So the effects from different risk cases are accumulated into a single estimation of the effects of the colony level. This is done by basically taking the formula which is normally used as a conceptual model for the independent action from the mixture toxicity models, except in this case, the different contributions are not coming from different substances, they are coming from different risk cases. And one very good feature of using this conceptual model is that effects are constrained between 0 and 10% and 100%, which means that we made sure by using this formula that bees couldn't die twice, which is important, obviously. And another very good aspect that Mima already mentioned before is that the overall predicted effect at the colony level is directly compared to the acceptable level of effect determined in the SPG, which is 10%, which means in a practical matter that we don't need trigger values anymore. So we just rely on the magnitude dimension as derived in the SPG. One aspect that needs to be mentioned is that the combined approach used the worst case exposure level from different scenarios, which may not necessarily overlap in time, but we felt that for a tier 1, let's say conceptual model point of view, that is acceptable in terms of conservativeness. Moving on to the next slide, which is my last slide, if I'm not wrong, which concerned the implementation of the approach for bumblebees and solitary bees. So as Sophie already mentioned at the very beginning of this info session, risk manager selected the undefined threshold option for the magnitude dimension of the SPG. which makes it basically not possible to carry out to work out a quantitative threshold for the low-rate risk assessment for solitary bees and bumblebees. Nonetheless, in this guidance document, exposure estimation and hazard definition for this group of bees has been made possible. We acknowledge that in most cases there was a lack of specific data, or anyway a paucity of specific data. Therefore, this led to considerable uncertainty, which in turn may have led to conservative estimates. Nonetheless, what I want to point out is that if the defined threshold would be available at a certain point, the same three-step procedure could be followed for the low-rate risk assessment, also for bumblebees and for solitary bees. And with that, I think I close my part of the presentation and I hand the floor to Brecht. Thank you.
Thank you, Alessio. So good morning, everybody. I will now continue by presenting Chapter 8, which is about time-reinforced toxicity, or in short, TRT. Next slide, please. A short overview of what I will talk about. First, I will explain the concept of time-reinforced toxicity and why it is important in the context of risk assessment. Followed by some information on how to test for TRT and how the GUTS model fits in this testing method. And finally, focus on the assessment scheme, which was included in the guidance document, which constitutes of a hazard part and a risk assessment part. Next slide, please. So first of all, what is time-reinforced toxicity? Important is to mention that this concept is not new. It was already included in the 2013 version of the EFSA B guidance document, but there it was called accumulative toxicity. And for this revised version of the guidance document, we've not only opted to change the name, but also modified the way of testing and assessing and to include it further in risk assessment completely compared to the previous version. Now, central in this concept of time-reinforced toxicity is Haber's law, and this law states that the same level of response will occur under different exposure regimes that produce an equivalent toxic load. Now, what does this mean? You see here this example on the slide. On the left-hand side, you have a situation where you have an exposure of 2 days, and in each of these 2 days, the organism is exposed to 4 units of a certain dose. So in total, 8 units of this dose. And on the right-hand side, you have the same total dose, so the same toxic load being 8 doses, but in this case, this is spread out over 8 consecutive days. And according to Haber's law, the response, or in case of bees, the mortality, will be the same in both cases. Now, if a chemical shows TRT characteristics, it will violate this law. And in that case, if in the right-hand situation where you have a longer period of exposure to a lower dose, will result in a higher mortality, higher response than what you would expect based on the information you get from a short exposure period to higher doses. So the toxic effects are reinforced by the exposure time. Next, please. Now, why is this an issue for the risk assessment? Well, the hazard assessment in ecotox, so not only for bees, but in general in ecotox, is in most cases based on laboratory studies with a fixed exposure duration. So in case of bees, you have either acute studies with an exposure that could last up to maximum 6 hours, or a chronic study which lasts for 10 days. And this approach is generally valid in case the toxicity is dependent on the dose. However, if this the toxicity is dependent mainly on the duration of the exposure, this is no longer a valid approach. And if a substance shows TRT, the duration of exposure matters. And in that case, the impact of low doses may be underestimated if the exposure period that was tested in the lab is shorter than what is relevant in the environment. So for example, for a bee, the worst case is that the bee is exposed throughout its whole lifespan. And this, of course, will be longer than the 10 days that is tested in the lab in the case of honeybees. There's also evidence from literature that TRT can occur in bees, and therefore the working group decided that it should be checked at least for each substance whether or not TRT is an issue. Next slide, please. Now, how can we test for TRT? Well, again, Haber's law was used as kind of the concept behind the methods that we've developed. And if we would express this law mathematically, then this is nothing more than the product of the concentration C and the time T, which is equal to a constant value. If you would express this relationship on a logarithmic scale, so plot both the concentration and the time on a log scale, you get a simple linear relationship. So being a straight line with a slope of -1, as you can see here on this graph on the slide. So the dotted line, the black dotted line, is a simple linear relationship between the concentration and the time with a slope of -1. And now testing for time reinforced toxicity can then simply be done by comparing the 10-day LDD50 and the 27-day LDD50, because if your Haber's law, if your product or substance follows Haber's law, then this linear relationship, you can derive from this linear relationship that the difference between the LDD50 at day 10 and at day 27 would be a factor of 2.7. However, if your substance shows time reinforced toxicity, then your LDD50 will be lower than what you would expect. So this factor of difference would be higher than 2.7, and you would end up below the red dotted line. So if this difference between these two values is higher than 2.7, then you know, or you have an indication that your substance shows TRT. This 10-day LDD50 can in principle be derived from a 10-day toxicity test, but what about this 27-day LDD50? Well, in most cases, we do not have a test that lasts for 27 days, and that's where the GUTS model comes into play. You can fit a GUTS model to experimental data from the first 10 days from a 10-day toxicity test, and then use this model to calculate or to extrapolate your mortality and calculate your LDD50 after 27 days, and then compare these two values. Next slide, please. Now, what is this GUTS model? GUTS stands for General Unified Threshold Model of Survival. It's a toxicokinetic and toxicodynamic model. And this type of models account for the dynamics of the exposure and effects over time. And therefore, this is also a naturally suitable method also to take potential TRT properties into account. And the big advantage of using GUTS models is that you can fit them to the data, to all data points of a test at once. So for example, if you have a 10-day toxicity test, you use the data for survival from day 0 until day 10, so all information from your test at once, compared to, for example, calculating an LDD50 at a single time point will only use observations made at that same time point. So you kind of neglect a part of the information that you can obtain from your tests. Here on the slide on the bottom, you see a kind of a schematic representation of how the GUTS model works. I will not go into the details because the time is a bit too short for that, but please refer to the literature on this model, which is available. And there's also an EFSA scientific opinion on TKTD models in which this GUTS model is discussed. But what you need to remember for now is that there are two different types of models. So to say, you have the SD variant of the model and the IT variant, which both calculate the way the survival is calculated in both situations is different, and we'll take both these models into account further in our assessment scheme. Next slide, please. So then we come to the assessment scheme. This graph is kind of a schematic overview of the whole TRT scheme as it is included in the revised guidance document. To note here is that it falls apart in two different parts. On the left-hand side, you have the hazard part of the assessment scheme, and there the idea is that we want to find an answer to the question: does the substance we are looking at show TRT or not? And this part of the assessment scheme has to be performed for all substances. On the right-hand side, you have the risk assessment part, and this only has to be performed in case a substance has been shown to show TRT. One important thing also to note is that the scheme only needs to be run through for honeybees. And why is that? That's not because TRT cannot occur for bumblebees or solitary bees, but simply because we need chronic toxicity data in order to test for TRT, and this is at the moment only available for honeybees. Next slide, please. Now let's go a little bit deeper on the hazard part of this assessment scheme. As I said, the idea is that we check here, does a substance show TRT, yes or no? And the starting point for this scheme is the 10-day chronic toxicity study according to OECD 245, simply because this data is already available in the dossier. And in addition, we've done an analysis based on data from studies with a longer duration, so lifelong studies. And there we've been able to show that if you fit a GUTS model to the data from the first 10 days of this test, that you can use this model then to predict with a high reliability also what happens in for longer exposure durations, at least if sufficient mortality is observed. So in most cases, then the data from this 10-day chronic toxicity study can be used as a good basis to check for TRT. Then a first real step in the assessment scheme is kind of a screening step where you check, is an assessment necessary, yes or no? And this was included to avoid that we have to go through the scheme for substances of really low toxicity, for which even if they would show TRT, this would not result in an unacceptable risk. And there the threshold is that there is less than 10% mortality, corrected mortality, so treatment-related mortality at any dose higher than, or at any dose equal or higher than 100 micrograms of active substance, per B per day. So if that is the case, then you do not need to go further with the assessment, then you are safe. The second step is to check whether the observed mortality in your study is high enough to fit the GUTS model. As I mentioned, this GUTS model fitting and extrapolation of your mortality is only possible if you have a sufficient, at least some mortality throughout your 10-day test, so that your GUTS model can learn from this and you can have a reliable model fitted to your data. And we've set the threshold to 25% mortality, so it should be possible to calculate at least an LDD 25 at the end of your test at day 10. So you need at least 25% mortality at any of your doses tested at the end of your study. Next slide, please. Now, if we assume that this is the case, then the next step would be to fit your GUTS models. There are two variants, as I said, the IT and the SD model. Both need to be fitted to the data. And during the public consultation, we got some concerns related to this GUTS model, that normal risk assessors are not GUTS modelers. Will we be able to do this? And the answer should be yes, because there are some tools available, semi-automated tools, software that can be used to fit your GUTS model. And in addition, this procedure will also be implemented in the calculator that will be developed. And once you've done that, fit your GUTS model, then you can check your model performance and select the best out of these two fitted models for further use. And this is done using the normalized root mean square error. This is a quite standardized metric which compares your fitted or your model predictions with the experimental data. And then in the fourth step, you compare then eventually the 10-day LDD50 and the 27-day LDD50. Both values can be derived and can be calculated using your GUTS models you fitted before. And then you check whether or not the difference is more equal or more than this factor of 2.7. If neither of your models, IT or SD, indicate that there is TRT, then of course you have no concern. If both models indicate TRT, then it is confirmed and you need to proceed to the risk assessment. And if the outcome between the IT and the SD model would be different, then you should base your conclusion on the best fitting model using this normalized root mean square error to select the best one. Next slide, please. Now, what to do if your GUTS model cannot be fitted? Well, first of all, to mention is that this will not happen very often, because if your mortality, this will only happen if the mortality is higher than 10% at the end of your study. So you cannot use your first screening step to rule out any further assessment, but still below 25%, so you cannot fit the GUTS model. Or alternatively, it could also happen if your mortality is below 10%, but the highest dose which you've tested in your study is below 100 micrograms per B per day, then this first screening step can also not be used. So what to do then? Well, you have two options. Either you perform a new tailored TRT study, and this can then be done either with higher doses or you can use a longer duration, so extend your study beyond the 10 days of a standard OECD 10-day test. In both cases, the idea is that the mortality in your study will increase so that your GUTS model can be fitted. Note that also if you perform a study with a longer duration, GUTS model fitting will still be needed because in most cases, it's possible that your study with your longer duration is still limited to, for example, 20 days or 15 days, and then you still need to extrapolate to these 27 days. However, if if you perform a good lifelong study and there would still be no treatment-related mortality observed in that study, then this could be an indication that there's no concern for TRT. The alternative is if you do not want or you cannot perform a new study, that you assume that your substance shows TRT properties with a worst case assumptions, which is then a Haber's exponent of -2, meaning that in this linear relationship I showed earlier, the slope will not be -1 but -2. Next slide, please. The final step in your hazard assessment is then to calculate the lifespan dose response. As Alessio has explained, we need the dose response in case of for the risk assessment, and in the risk assessment for TRT substances, we consider the longest possible exposure, which is the whole lifespan of a bee. There will be two scenarios, a summer bee scenario and a winter bee scenario, and for both of these cases, we've considered a lifespan of either 27 days in case of summer bees or 82 days being 6 months for winter bees. If your substance was identified as being a TRT substance, then you have your GUTS models fitted and you can calculate those responses easily from your GUTS models. If you assumed a Haber's exponent of -2, so worst case assumptions, then you can determine your dose response for 10 days, which will often be a surrogate dose response, and then apply a factor to shift this curve to the left to get an appropriate dose response for the relevant lifespan. Next slide, please. And then we come to the risk assessment. So this, as I said, this only needs to be performed for substances that show TRT. In case of the summer bee scenario, we've considered the lifespan of 27 days. This was derived from a large data set on background mortality of honeybees, and it was the median value. And in this case, the exposure estimates are the same as for the standard risk assessment. So the same value, the same equations are used, and most of the parameters will also be the same, except from the time window, which in this case will be the 27 days instead of the 10 days in the standard risk assessment. And also the pollen and nectar consumption was altered, considering changes in the diet in relation to the executed tasks, which will change throughout the lifespan of a bee. And this results in specific shortcut values that then needs to be taken into account in calculating the level of exposure. And then the predicted individual level of effect for TRT is then calculated based on the exposure and the lifespan dose response. And this will replace then the standard chronic term in the overall effect prediction explained by Alessio previously. Next slide, please. And then finally, the winter bee risk assessment. This risk assessment was included because, especially in winter, bees can be exposed to these low doses for a very long period of time. And here we've considered a lifespan of 6 months. This is a very rough estimate, but it was based on honeybee sightings database, and it was just the winter period was considered the time where there was little bee activity, and it was about 6 months. So therefore, this value was chosen. And in this case, a specific exposure model is used, so specific equations and also specific parameter values. For the food, it is considered that only contaminated honey is consumed. We have specific RUT values available for honey. And there's also DT50, which is taken into account specifically for honey, but in lack of specific data, it is now considered, at least for the tier 1, to be 1,000 days. But this value could be potentially be refined based on substance-specific data. And then you use this exposure model to calculate your predicted exposure quantity, your PEC value, and use this in combination with the lifespan dose response to get your predicted level of effect. In contrast to the summer bee assessment, this is a standalone assessment which has to be performed in addition, because here we only have this chronic adult dietary exposure through honey, and the other risk cases are not relevant. And with that, I have come to the end of my presentation, and I will give the floor back to Mima for the Q&A session. Thank you.
Thank you, Alessio, and thank you, Brett. I would suggest to start immediately with the Q&A section. We will have this until 11:30. So I give the floor first to Alessio. Please, Alessio.
Thank you, Mima. So I will start with one question which was received in the registration phase. There seems to be a concern about the fact that this new hazard assessment is changing a bit the way that it was done before, especially the shift from the NOAEL to the dose response seems to be creating some concern. And the question is, will this mean that the industry will have to repeat most of the previously conducted studies in the next few years? The very simple answer to that is no. So we've considered that, and that is why we had this consideration of the surrogate dose response for in case where you don't have, let's say, enough data to fit your dose response. This is also, we've considered also the default assumption for the TRT assessment that Brecht has already mentioned. So in fact, there is no specific need for redoing studies that were already there. There might be an advantage in some case because perhaps you want to have a more substance-specific dose response instead of relying on a surrogate dose response, for example. But this is completely in the hands of the applicants, whether we wish to redo it or not. What will need to be redone is for sure a reanalysis of the data. That is for sure something that will be needed, but this should not be a particular issue, I guess. So another question which was put now in the chat is how will the data for bumblebees, when submitted, be used if the lower tier risk assessment will not be implemented for the time being? So I think there is a kind of a double answers to that. One is concerning how this data will be used in terms of decision making, and this is something that will depend very much on the implementation plan foreseen by the EC, and how additional criteria which are not in the guidance document will be used for decision making. From the risk assessment perspective, the data should be used for predicted effects. I mean, they could be used for predicting effects, which can be used as an additional line of evidence that could be considered in the risk assessment. Another question concerned chronic product studies are often only required if the product is more toxic than the active. Yes. So basically the question is, what if you don't see any effects in the product studies, and then how can we compare the endpoint? The answer to that is very complex, and it will be a case by case, but there is a section in the guidance document that tries to explain how to deal with specific cases where either you have to rely on surrogate dose responses for one or two cases on the two sides of the comparison. So I will point you to chapter 6 of the guidance document for that specific question. Another question was when deciding to run a chronic toxicity test on formulation containing one active substance, the difference in the acute toxicity between the active and the formulation is higher than a factor of 3. And the question is where this factor of 3 coming from, basically. So this is, in fact, the factor of 3 is considered to be a fair estimation of experimental variability between the same test be repeating in different instances. In fact, we've seen cases where this variability was even larger than a factor of 3. But specifically, this factor is mentioned in one of the European Commission guidance, which has to do with the equivalence of batches. So there is the main reference that you can find. But just to be clear, so this is the, let's say, an estimate of a fair variability between exactly the same substance being tested multiple times. Another second question was if many conformulants have insecticidal activity, so does it make sense to differentiate between formulation with one active substance? So the issue is if there was an insecticidal activity by one coformulant, this should have been picked up in the acute studies. So the comparison between the active and the plant protection product would already tell you that the plant protection product is in fact more toxic, and in that case chronic studies and larvae study will be required anyway. I don't know if I have time. I will take another one perhaps, and then we can reassess. The other question was, is it okay to test a single substance, single active ingredient formulation to conservatively cover both the active and the formulation? So as I said in the presentation, this is okay for difficult substances. So when you really have troubles in testing the formulation because of these or the specific physical chemical properties, but otherwise for any active substance authorization, the active substance testing, it's mandatory, especially for honeybees. And that now I put this in the hands of Mima. So do we have? Shall I move on? Shall I pass the floor to Brecht at this point?
I would say that you might have still a couple of minutes if you want to address the last question, and then you can give the floor to Brecht.
Okay. So one question was how to calculate LDD50 when you have only limit test result. I think this was covered in the presentation. That's exactly the example that I made on the surrogate dose response. One question is requiring an example of calculation of a combined toxicity. And I will point you that to there is an example in the guidance document in table 29. So please have a look at that in chapter 7. I think that will be self-explanatory. The last question I will be taking is, based on point estimates, currently the lowest endpoint is used for the risk assessment. Now the full dose response curve is considered. Which endpoint is now considered to be the most appropriate in the risk assessment? The one with the most robust dose response or the one with the lowest LD50, even if this is only a point estimate? So this is a very good question. And in fact, I had a slide on that, but then I had to cut it for time reasoning. But the idea is that in the first instance, the idea is to combine different data sets, see if it is possible to combine different data sets. If the different data sets are more or less telling the same story, then you can fit the model to the combined data set. If this is not possible because the two data sets are really telling something different, then yes, you should be looking at the reliability of the underlying studies. And if you have indication that one is more reliable than the other, this is the one that should be, in fact, used for deriving the dose response. And there's also consideration about how to deal with situation where one is a surrogate dose response and one is not, as I already mentioned. So that is already kind of explained in chapter 6 of the guidance document. And with that, I'll pass the floor to Brecht for his bit of question and answer.
Thank you, Alessio. I also will start with the question that has been received previously to this info session. Has the winter bee assessment been road tested, and is it relevant to extrapolate from short-term tests on summer bees to long-term and to a long-term endpoint for winter bees? Well, first of all, according to the road testing, the winter bee assessment has been tested for a limited number of substances and uses, and we found that it's a workable assessment. However, at the moment we cannot really give an indication of a certain pass or failure rate that can be expected because, yeah, that of course has not been tested to a large number of substances. And in relation to the winter bee endpoint derived from a summer bee test, yes, of course, this is not ideal. Ideally, you should have winter bees tested. However, the tests with summer bees, the standard chronic toxicity test, is what we have currently available. There is no guideline available to test for winter bees. And if we look at the literature, there's also little information available on differences in sensitivity in terms of sensitivity for winter bees and summer bees. However, generally winter bees seem to be less sensitive to some extent compared to summer bees. So in that respect, if you derive an endpoint based on summer bee data, this should cover also for potential effects on winter bees. And then moving on to questions received now during this session. First one, it would be very important to consider the validity of GUTS models, especially for low toxicity pesticides that do not show toxicity in the first 10 days, but show TRT if we prolong observation period to 20 days, for example. How is the GUTS model calibrated? Well, as I mentioned, we've used all data that is available from literature, from tests which had a longer exposure duration. So, for example, there are several publications on chronic toxicity tests that were extended beyond 20 days. And we've used these data and checked the data from the first 10 days of this test, fitted the GOTS model to those, to the data from the first 10 days, and then made model predictions for these longer exposure periods and compared those to the data from these longer exposure periods from these so compare this to the experimental data, and the modeled data and experimental data fitted really well. So even if you see a low toxicity in your first 10 days, if you have at least something like probably less than 25% is enough, but to be sufficiently robust, we've selected this 25%. But even if you see a bit lower mortality, you can fit your GOTS model and it can predict very well what happens later on. So normally you should also be able to see what happens later than these 10 days. And if so, TRT is not something that happens after 20 days, after 10 days, either your substance shows TRT or it doesn't. And so we are confident that based on the methodology that we've developed, that you should be able to screen out those substances that show TRT. Next question, the GOTS model assumes constant exposure over 27 days. This is never the case in the environment. Exposure levels vary, normally decline over time. Does the model still apply? And this is a very, it's a good remark. It's true, exposure will vary over time, but this is also the case for a shorter period, like for 10 days. And there also we assume in the risk assessment the constant exposure. We base our endpoints also on this constant exposure. So for the first tier risk assessment, this is just the assumption that we make. Next question concerning the GOTS model, will it be available as an utility under the EFSA calculator page online, which will be available hopefully soon? Yes, I mentioned this in my presentation, it will be available, and also references to the methodology, like the software or R packages that are currently already available, are also in the EFSA in the new revised guidance document and are freely also available online. So it should be fairly easy to retrieve them. Then a next question, if you could prove that exposure in pollen and nectar is below 10 days with exposure refinements, could you then ignore TRT, as you have already tested in the lab for as long as bees would realistically be exposed? Yes, probably yes, because of course the central thing in only TRT only matters if you have a prolonged exposure to your substance. So if you can exclude that in a way, then further assessment would even if your substance shows TRT, this would not be relevant in real life. However, the guidance document does not really give any clear indications, at least not in the TRT chapter, on how to do this in practice. Still have some time for a next question. TRT includes the screening only for low toxic considered endpoints. However, for limit tests from old applications, the mortality is not always known. In this case, Haber's exponent of -2 has to be assumed and TRT will be triggered by default. So for EU agreed endpoints from old EFSA conclusions, TRT needs to be assumed by default. Can in this case the chronic product study be used for TRT assessment and subsequent risk assessment? Well, even if that comes a bit back to a question that Alessio answered previously, you have this old agreed endpoints is indeed in the EFSA conclusion, but the study and the data is available in the evaluation report of the active substance. So you should have this data available, the necessary data available to do your TRT assessment, even for old studies. So you can use your old active substance studies to perform your TRT assessment. And if a chronic product data would be available, then you can indeed also use this, and you should also use this in your TRT assessment. So that could also be a second option to go for. And with that, I think time is I'm out of time, and I will give the floor back to Dominika.
Thank you, Brecht. So we are very close to the coffee break. Before closing, there are 2 points, 2 questions that maybe I can say something. One is relation of whether the data for bumblebees and solitary bees should be submitted when test guidelines become available. I think this is also addressed in the chapter 6 of the guidance document, and of course, since those are part of the data requirement, we consider that they should be made available. The other point, I think, I don't know if this was addressed, but there were some questions related to the complexity of the TRT assessment, but this will be supported by the calculator, where then there will be a full implementation of the TRT in the calculator. So with this, I think we can close 2 minutes in advance the second Q&A session. We will have now a short coffee or tea break, and we will propose to start again at 11:45 for the third session and the third and the last session of today. So see you in 15 minutes. Okay, welcome back. We are going to start the last session of this event. The speaker of this session will be Jacoba Wassenberg and Csaba Szentes. And I pass the floor immediately to Jacoba, that she will present the chapter 9 related to the sublethal effects. Please, Jacoba.
Thank you, Mima. So hi, everybody. So as Mima said, I'll introduce chapter 9 to you. Next slide, please. So why do we want to include sublethal effects in the guidance document? As you've heard, we have a specific protection goal set, which for honeybees relies on a maximum acceptable percentage of a 10% reduction in colony strength. And what we do in the lower tiers, as you've heard Alessio explain, is to predict this colony level effect based on mortality endpoints in laboratory studies. And then a concern that has been voiced is that the real effect on colony strength is underestimated by doing this, because sublethal effects may also impair colony strength. Next slide, please. So if you talk about sublethal effects, what do you really talk about? This issue was already discussed in the scientific opinion of 2012. And what we did now for the revision of the guidance is that we added a narrative review of sublethal effects that had been published since then. It's added as a supplement to the guidance document, and you will see immediately that's a very long list in a very broad array of different types of endpoints that were looked at. So the studies that we found were done with many different species of bees, but mostly the honeybee. But they also look at very different effects, such as any kind of learning performance, to thermoregulation, to lots of different physiological parameters. And it became quickly clear to us that we simply cannot include all of these in a risk assessment. If you've read the new guidance already, you may have noticed that the sublethal endpoint that was included in the previous version of the guidance document, the hypopharyngeal gland, is not there anymore. So when we were thinking about sublethal, we revisited also this parameter. We found that, well, first, this hypopharyngeal gland is a gland in the brain of the bee that is, if you have, it can become smaller because of a pesticide effect, and that is supposed to have an impact on the ability of nurse bees to care for the brood. This thing is difficult to link to the colony strength. There is no demonstrated link between the two as yet. Also, importantly, there are still no internationally agreed guidelines for how to exactly measure these effects. And then we also looked at the number of studies that we had received during the past 10 years when this guidance was applied by EFSA for the active substance risk assessment, or at least looked at. There were a number of studies, not too many, but there were a couple. And what we found was that if you use the endpoints for the HPG and the chronic mortality standard endpoint, actually this HPG risk assessment had little added value, because the chronic risk assessment would always be more strict. So taking all that into account, we concluded that this is not a relevant endpoint anymore. Can I have the next slide? So the strategy that we took was to try to use the standard risk assessment and make use of existing studies as much as we could, and also to look in the regulations for clues as what to do. And then you see that the regulation 1107 already tells us to take into account honeybee behavior when we decide on the acceptable risk for honeybees. And in the data requirement regulations, sublethal effects are mentioned. It's needed to report any sublethal effects that you observe in your laboratory studies, and also in special studies that may be needed. And in the higher tier studies, a sublethal effect can also be addressed according to the data requirements, and there specifically foraging behavior and the homing flight test are mentioned as examples that are relevant. Next. So the strategy that we took in the end is to focus our efforts on effects on foraging behavior. This has a clear mechanistic link to the colony strength, because the number of food that is taken to the colony clearly impacts the number of adults that such a colony can sustain. Also, it's a parameter that can be studied in higher tier studies. Though we do acknowledge that there is no clear proven link to the effect on colony strength. So the quantitative link is not there yet. We hope modeling could provide some help for that in future. But at the moment, we end this risk assessment with a conclusion of concern indicated or no concern indicated, as opposed to the rest of the risk assessment where we end with a conclusion on risk, high risk or low risk. This part of the assessment focuses on honeybees only because it's a new approach that we want to gain experience with before we apply it to all bees. And additionally, we are using the standard laboratory data in the earlier steps of the risk assessment, and those studies are mostly available for the honeybees. Next, please. So this is the overall scheme, and you don't have to read it from here. I'll go through step by step, but it's just to let you know that we're using a tiered approach here, starting from the simpler endpoints in the standard studies and going through more complicated steps later on, only when needed. Next slide. So before you really go into the sublethal assessment, it's good to check if you already have field study data available, because if you have field studies, and we're going into that a little bit more detail in the into field studies in the final presentation today. But if you have those field studies and you can use them to show compliance with the SPG, then you really don't have to worry about sublethal effects anymore, because the colony strength parameter is the important endpoint here. So even if sublethal effects had occurred on foraging behavior, clearly they didn't impact the colony strength for more than 10%, which means that you have no concern for sublethal effects as well. On the other hand, if your field studies show a high risk, that they don't meet the SPG, then you conclude a high risk and you don't have to look at sublethal anymore either. If you don't have field studies yet, we recommend first to do your mortality-based risk assessment to see if in the end you would need field studies there. So where you go into this scheme only when you have a lower tier risk assessment that shows a low risk based on your mortality endpoints, and then you go into this scheme. Next slide. So in step one, what we do is we use the mortality endpoints from the standard studies. So we look here only at the acute oral, the acute contact, and the chronic oral studies. We're leaving out the larval study, which makes sense because the larvae don't display much foraging behavior in the field. So the first endpoint to take here is the LD10, and we estimate a no concern level for foraging behavior at a factor of 10 below the LD10. If you have a look at the graph here in the lower left side of the slide, you can see the dose response curve for the mortality data. There is the LD10 identified there. A factor of 10 below that is a very low exposure level, and we estimate that at that level there wouldn't be any concern for foraging behavior. Should you be in a position not to have an LD10, you can alternatively use the LD50. And based on a substance with a worst case slope in this respect, this goes back to the presentation of Alessio before, a factor of 50 on the LD50 should lead you to that same level for no concern level for foraging behavior. So these dotted lines there in the graph, the green dotted line or red dotted line, is the no concern level. And this level you compare to the predicted exposure quantity for your specific study, because you're doing this separately, individually for the 3 risk cases for acute contact, acute oral, and chronic oral. So you compare those to the PEC, and the no concern level should be above the PEC. If not, you potentially have a concern. Can I have the next slide? Now, we did try to look at to investigate those factors of 10 and 50. looking at literature data. For the LD10, there's not so much data, but for the LD50, we have a couple of sources that inform us about the realism of these factors. One is the ring test for the OECD homing flight guidance document, where a reference substance was used, and we could see that in all cases, the no effect dose for the homing flight was somewhere between a factor of 3 to a factor of 15 below the LD50, which shows that that factor of 50 is definitely conservative. In addition, last year there was a big review published for sublethal effects, where the no effect dose for sublethal effects, the lowest effect dose for sublethal effects was compared to the LD50. So we took this data set, we added the chronic data where available, and we focused on the subset of effects that are relevant for foraging behavior. And then also we found that this data set broadly confirms the value of 50. This analysis is presented in the supplementary document if you're interested in the details. Next slide, please. So as an example of this first step, what we see here are the results of a chronic 10-day adult honeybee feeding test. So you have 2 control groups here and a reference substance, and then 5 doses of your product. And the LD10 here is indicated in yellow. The LD10 it's at 15.52 microgram active substance per bee per day. Then we calculated the predicted exposure quantity for this specific risk case of dietary chronic for an example gap, and it came out at 2.12 microgram active substance per bee per day. So comparing those, you can see that the ratio is below 10, which means that there is a potential concern triggered, and you would have to go to step 2 here. Next slide. In step 2, you use those behavioral data from the standard studies that are reported always in the study reports. So the acute chronic, the acute oral, and the chronic oral study. There are several sublethal effects reported. There is the food intake level, and there are different types of behavioral abnormalities. And you can use those data to derive a no effect dose and compare it to your pack again. Next slide. So I'm going to give you an example of this as well. So here is the table of the behavioral observations in this same study. So on the horizontal lines, you first have the 2 control groups, and then the 5 treatment groups, and each treatment group has 4 replicates. So what happens in these studies is that every day when the mortality is assessed, also each replicate is assessed for the number of bees that shows behavioral abnormalities. And normally study reports should tell you which categories they looked at and how they did that. So here we have a number of categories that are moribund or affected or cramping or apathetic. In the table, I've highlighted in yellow all the instances, all the days where bees were seen that showed any kind of behavioral abnormality. And as you can see here, the behavioral abnormality is clearly increased with an increasing dose. So they started to occur at the second to lowest treatment level and were quite prevalent at the highest treatment level. Next slide. So the guidance tells you how to analyze these statistically. So how to compare the number of affected bees in each treatment to the control. If you do that, you find in this study that the NOAD is at the lowest treatment level. So at the concentration of 156 microgram per kilogram. Using the food intake level at this dose, you find a no effect dose of 4.4 microgram active substance per bee per day. And you can compare this to the same predicted exposure quantity, and then you find actually that in this case the no effect dose is higher than the predicted exposure quantity, which means that you have no concern triggered for behavioral observations here. So no concern from sublethal effects. Next slide. Should you not be so lucky and you're still cannot exclude a concern, there is guidance on how to refine these observations. You can do specific assays that are like the standard studies, but with improvements to better define the level the sublethal effect level, mainly to include lower doses, increase the number of replicates, and also we highly recommend to include blind observation here, because a mortality assessment is quite straightforward, but a sublethal assessment is quite subjective, and it's important to standardize this and to not know which concentration you're looking at when you're interpreting the bee behavior. One specific assay that you can do is a homing flight test, which is a guidance document published by the OECD 2 years ago. This covers acute oral exposure, so it can be refined for concerns resulting from acute oral exposure only. Again, here you derive a NOAT and you compare it to your predicted exposure quantity for the risk case. Next slide. Then if you still have a concern, you could think of doing studying foraging behavior in semi-field or field studies. We're interested here mostly in the initial period after the application. So in semi-field studies, this is also possible to study. Parameters that we expect to be most influential for the specific protection goal are the amount of pollen collected per flight, or as a proxy, the number of bees returning with pollen. And potentially, if you have a concern for mere homing tests, you could look at the duration of a foraging flight after a little bit more realistic exposure than in that OECD guidance document. Now we have set the acceptable effect level here at 10%, in line with the specific protection goal of 10% for colony strength, which could be quite conservative, this one-to-one extrapolation, but in lack of better data, this is the trigger that we've set. And then the next slide, please. So in the final step of the risk assessment, you can, of course, go to full field studies and directly study your specific protection goal. And as I explained before, this would cover sublethal effects. And then Csaba will now tell you much more about what these field studies should look like. So I will give the floor back to Csaba.
Thank you. So we can go to the next slide immediately. So now we change to higher tier tests. Next slide, please. The menu for this section is the following. First, I will talk about the field studies for honeybees, then some general issues for higher tier testing, then other type of studies for honeybees. You may find this order as not very logic, but when I tested basically to explain and grasp the main concept seemed to be easier in this order. Then I will give the floor to Jakoba, who will talk about the studies for bumblebees and solitary bees, and the last slide will be about the conclusion. Next slide, please. So, field studies for honeybees. So the method is not new. Already used EPO guidance describes the main requirements for conducting the field studies, and what is recommended by our guidance is basically took these recommendations, so kept these recommendations, so it's based on that. The main characteristics of the study that we have some colonies next to the field, they are free foraging. The study lasts, in our recommendations, at least for 2 brood cycles, which is 42 days at least. But for TRT substances, it should take longer, including an overwintering period. And of course, we have a treated group, so a number of treated fields and a number of control fields, but we have to compare later on. The observations. There are many observations possible, but the main observation what must be done is the colony strength. Many other endpoints are traditionally considered, but they are only supplementary, so not mandatory endpoints. Why? we are saying that it's enough, basically, if you consider only the colony strengths. This is illustrated in the middle part of the slide in the green flow chart, because simply the SPG is linked to the colony size, the colony strengths. So if the colony strength is studied appropriately, then we can address the SPG in field realistic setup. How the colony strengths can be studied with the traditional Liebenfeld method, but also digital photography is recommended. We all aware that there are even newer technologies, more modern technologies. They are welcome. The working group could not recommend it because still some experience has to be collected with them, but some of them are very promising. Next slide, please. Okay. Some generalities for the field studies. So we have some definitions like site, block. So what is a site? What is a block? What is a landscape? What is a field? These are illustrated in the graphs in the picture in the slide. The hive is next to the field. The landscape we described as about 4 kilometers around the hive. A block, which includes a control site and a treated site. The requirements is that there should be some similarity within the blocks. So for the control and the treated, the focal crop should be, of course, the same. Even the variety is proposed to be the same. Yes, can you hear me? Because I got a message that probably something is wrong. Can you confirm that everything is fine? Yeah.
Yes,
okay.
Csaba.
Okay, thank you. So the field size should be similar, the soil type should be similar, the pesticide use history on the two sites within the block should be similar, and the variability of the colonies or nest should be as similar as possible. So some efforts has to be made to reduce the variability, and the landscape characteristics also should be similar. Between the blocks, we need a certain distance in order to consider them as independent. So the working group defined this as at least 10 kilometers. And compliance with the EXEG, this is the exposure assessment goal, has to be demonstrated. So the exposure element of the field studies. And the next slides about the exposure element. So please, yes. So conceptual level. We have the PEC value. You heard about the PEC value in the morning. This represents the exposure in realistic agricultural settings. So with the equations, what in another presentation had been shown. Here, for the field study, we need another value, which is called EED. Estimated exposure dose. This represents the exposure in the actual higher tier study. Then, if we go to the next slide, it's basically the same, just added that we have to compare these two values. If the EDD, so the exposure in the actual field study, is higher or equal to the PEC, then we can conclude that the study represents very well the expected exposure in agricultural settings. That is the aim. Next slide, please. Which shows how to calculate, how to derive the EED, the estimated exposure dose. Again, we have a similar equation, mathematical model with similar parameters. It's very similar to the PEC, but lower number of parameters are used. Why lower number? The logic, what I explained earlier, is again the same. Why we have lower number of parameters here? Because if you look at, I don't know if you can read the second row, which says concentration. It has to be measured. It must be measured in an effect field study. In the PEC part, this concentration, the same concept, the concentration had been estimated by default values, but we don't need those parameters to estimate these values because they are measured here. Nevertheless, some other parameters can be used, and the best available knowledge can be used for some of the parameters where it says tier 1 or tier 2, means that GAP or active substance specific parameterization can be done here. Even some measurements can be done in the concrete test fields. Okay, with the same logic as for the PEC, at the end we can get a test field specific EED for the 3 risk cases. But this is only for one field. We have in a number of fields, so the same calculation has to be repeated for every field, which result in a data set. For this data set, the mean and the median has to be calculated, and this will be the subject of the comparison, which is indicated shown in the next slide. Yes, so basically we have to do 6 comparison. So we have 3 PEC values for the 3 risk cases, but we have 6 EED values because mean and the median for the same risk cases has to be taken into consideration. And if all the EEDs are higher or at least equal than the respective PEC, then we can conclude that the exposure aspect of the effect field study represents well the realistic agriculture settings. Next slide, please. Still on the generalities, so the statistical paradigm. So probably you have heard, many of you, I'm sure, heard about that, the new guidance document as for the equivalence test, which is the bottom part of the slide. But first, I would like to talk about the upper part of the slide, the difference test. So first of all, difference test, equivalence test is not a new statistical test. It's just the concept, the conceptual level. So the difference test is the common statistical paradigm. What people who are dealing with toxicology, ecotoxicology, and has to compare a treated group with a control group, they use on daily basis. Generally, the difference test. Here, the aim of the test is to prove that there is a risk. There is a statistical difference between the 2 groups. The null hypothesis, no risk. The alternative hypothesis, there is a risk. The baseline for a difference test is a 0. 0 means theoretically 0 difference between the 2 groups. The horizontal lines in the slide represents the comparison already. So it's 3 theoretical cases when the statistical test already compared all the replicates in the treated with all the replicates in the control. So that's why it's not a point, it's a range, it's a confidence interval. So as you see, as long as this horizontal line overlaps the 0 baseline, the conclusion, there is no statistical difference, low risk. There is no risk. What in the practice it means that there is no motivation for reducing the variability. Why? Because the higher the variability is, the wider this confidence interval, more chance that it will overlap with the 0 line. Therefore, there is no motivation for reducing the variability with the differences, which is not a good thing. The lower the variability is always the better. Nevertheless, predefined study design with fixed power, so alpha and beta parameter, are needed here. And many of you remember to the story that the 2013 guidance prescribed a very big field study design. This is because of that. Now we are proposing the equivalence test, which basically is the opposite of this one, is the upside down. To prove, the aim is to prove that there is no risk, the null hypothesis high risk. The baseline is different, is not the 0 anymore, is the delta. The delta, what is this delta? Is related to the acceptable difference, basically, we can translate here to the SPG. So for honeybees, delta is a 10%. And here, if the confidence interval overlaps the baseline, then it's high risk. Yes, anytime it overlaps or on the wrong side of the picture, it's high risk because there is no equivalence. Equivalence is proven only if the confidence interval does not cross the delta line. This type of statistical paradigm motivates reducing variability. And the good thing is that no predefined study design is needed. What is needed to demonstrate that the treated group and the control group are equivalent. Next slide, please. And then we can go immediately to the next slide. So it is about some other study types, but first I have to explain quickly a strategy. So basically 3 types of higher tier tests for honeybees. 3 types of higher tier tests are suggested or recommended. The field study, we talked about the field study, but also semi-field study and colony feeder study can be used sometimes, but only in particular cases. First, the lower tier, the outcome of the lower tier risk assessment has to be investigated and decided and see what dominates the risk in lower tier. There are some methods in the guidance document which help the user to how to decide what dominates the risk. In particular cases, maybe it can be concluded that the contact route of exposure dominates the risk. So it gives the 95th percentile of the overall risk. It means that the contact risk is very high, the dietary risk is very low. Similar the case for when the larvae, the risk assessment for the larvae gives the majority of the risk, and the adults are basically not really touched by the pesticide, then the colony feeder study may be conducted. Next slide, please, which is about the semi-field study. So the logic is on the top part. Contact exposure dominates the risk. Foragers are affected because it's contact. Forager mortality can be reliably studied in semi-field conditions. And if we see less than 10% forager mortality, we can immediately conclude that the effect on the colony strength is less than 10%. So the method is based on, again, the same protocol what I already mentioned. This is an old one, but still gives good recommendations. Basically, how the test looks like: small honeybee colonies are kept in confined environment, which includes a flowering crop. It can be done in a single location. The whole test takes only a few days. We have normally a treated and a negative and a positive control. What observations has to be done? We focus on the forager mortality in 2 ways: dead bee traps and water permeable sheets. These are the main endpoints. In addition, there are some other endpoints recommended, which informs the exposure and then the colony size as well, but only as a supplementary endpoint. It is needed for the statistical analysis to see the proportion of the dead bees compared to the colony size. But major conclusion, so main conclusion, low risk, high risk, is not done based on the colony size. It's not for that. It's only supplementary here, as already was considered in the previous guidance document. My last slide, please, on the colony feeder study. Yeah, again, here the effect on larvae dominate the lower tier risk. Therefore, we assume that the brood are at risk in field condition as well. Brood effect can be studied in a reliable way in colony feeder studies. And again, if we see less than 10% effect, maximum 10% effect for the brood, then we can conclude that the colony size also impacted less than 10%. The method is based on Omen and the newer publication by Lukman and Smitzer. The exposure takes 9 days by offering spiked food ad libitum. A single location can be used with minimum alternative for each site. And the study should last for 2 brood cycles. Again, we have treated a negative and a positive control. And the main endpoint here is the covered brood, so the amount of brood cells with pupa, covered brood. If there is no impact on the covered brood, we reasonably assume that also eggs and larvae are all right. This is because the study lasts long, 2 brood cycles. And there are some additional supplementary endpoints. The statistical analysis is here as well an equivalence test, so the cat brood coverage between the treated and the control has to be compared. That was my last slide. I give the floor back to Jakoba.
Thank you, Csaba. So for the last part of this session, it's up to me to tell you about the higher tier tests for the other bee species, so the non-apis bees. Next slide. So first, on the bumblebees. For bumblebees, we've seen that the specific protection goal is based on colony strength, just like for honeybees, which is defined as the number of adults in a colony. Though, as we've also seen, the threshold here is undefined. Bumblebees are a bit different from honeybees in the respect that it's not so easy to assess the number of individuals. Because if you want to really go into the colony and count the individuals during a study, it's quite disturbing for them. But luckily, we have scientific information that tells you that at least for Bombus terrestris, you can use colony weight as a very good proxy for colony strength at the interim measurements. So that's what we're using here, colony weight. And in addition, bumblebees as a group are also different from honeybees in the respect that their queens have a solitary stage. They overwinter on their own, and in spring are the ones that go start the nest, forage, and attend to the brood all by themselves until they have made some workers to help them. So to acknowledge this, we found it very important to also acknowledge this, at least partly by looking at reproductive output. Now we have defined 3 study types here: field study, a semi-field study, and a feeder study. And we've largely leaned on the work of the ICP PRB protection group, non-APIS working group, who published last year a paper talking about study design, specifically with Bombus, especially Bombus terrestris. And of course, we've also taken into account other scientific work on bumblebees. So Bombus terrestris here is our main model species. Next slide. And the good thing about it is that you can order it from commercial breeders because it's used for pollination. So we recommend to start the studies with young and healthy commercial colonies of about 30 bees, so 1 queen and the rest should be workers. To get reliable results and to predict your effects well, it's important to minimize variation, as Csaba has also explained, and the guidance document gives you recommendations on how to do this based on the weight of the colonies that you have. Now there are 2 or 3 treatment groups depending on the test design. So your product, then a negative control group, and in a positive control group for the semi-field and the feeder study design. These bumblebee colonies will grow up to a point where they start making reproductive animals and then decline in weight again. So the working group has recommended a fixed study duration of 8 weeks, which should be able to cover this full development. But if this switch point hasn't been reached within the 8 weeks, it's also possible to extend the study a bit. And there is still the possibility to do more of a dynamic study design with different study endings at different time points for different colonies, but that will make the interpretation and the analysis of the results more difficult. Next slide. So there's 3 stages of data collection for bumblebees. First, you weigh the colony before you start the experiment. So you weigh the colony and you do an initial colony census by counting the number of workers and the queen. And there shouldn't be drones at that stage, or not many at least. At the initial stages, it's still possible to do that. And 1 disturbance event is okay. Then every week you weigh the colony. Simply by putting the whole nest box on the scale, you should know your the weight of your nest box and of potential feeders and stuff, so that you can subtract that and have the actual weight of only the bees and the nest itself. Then at the end of the study, you weigh the colony 1 final time, and then you freeze the colony and count all the individuals and assign them to sex and caste. Also, you count and assign the cocoons. And it's important to check that there are no parasitic cuckoo bees there, because that would conflict with your results. Next slide. Then for the data analysis, we're relying here for the colony strength parameter, specifically on the colony weight, so also at the first and the final assessment date. So at each time point, each measuring point, you compare the controls to the treatment to see the difference. Also, at the end of the study, you compare the reproductive output in the treatment and the control, according to the statistics that were just presented by Csaba. Next slide. Then for the different study designs, we have for bumblebees the field study as the highest tier test. It's very similar to the honeybee study in design, and actually you could imagine that you could combine these studies, so you have your honeybee field test and you also put bumblebee colonies in that same field to do the same test. You have to confirm your exposure by measuring the residues entering the hive. So there is the PEC determined from the exposure side of the equation, and in the study you determine your estimated exposure dose that was reached by measured residues in nectar and pollen. You can collect those from the bumblebees via bumblebee-specific pollen traps, but also you can take them directly from the bees, and you can measure the residues on the bees if you need a contact refinement. Well, you look at those same endpoints, colony weight and reproductive endpoints, and the test duration is 8 weeks. It should be 8 weeks as we recommend. Next slide. It's possible to do a semi-field study in cages, as shown here on the screen, with at least 60 square meters crop area per colony. An advantage here is that 1 site may be sufficient because you do a replication between the cages. That site should be representative of the area of use. And here you're not confirming your exposure with measured residues, but instead you're looking at the flight activity at the entrance of the colonies, which should meet a certain level at least twice on the day of the highest exposure, highest expected exposure. And in addition, there is a positive control in this test design, and the mortality, there should be clearly shown mortality observed here. Next slide. You're looking here again at colony weight and reproductive output. And the study design is like this, that there's 2 weeks of foraging in the cage to the treated crop. And then there is 6 weeks of freely foraging time in a pesticide low area, after which, during which the bees are still monitored. And then after that, the study ends. Next slide. Then for bumblebees, there is the option as well, just like for the honeybees, to do a feeder study. This covers dietary exposure only, and it has a spiked sugar solution or spiked pollen patties that are given directly inside the hive. So the bees here are put in a in an area where they can forage outside the field, but their exposure happens inside their nest. Treated colonies and control colonies are put together in a block design using this recommendations as shown on the screen here. So there should be at least 2 meters between the colonies within a block and at least 10 meters between the blocks. But then you can use one site, just like for the semi-field study, which should be representative of your area of use of the product. In this case, the exposure is a calculated estimated exposure dose is calculated based on the offered concentration in the sugar solution or the pollen paddies, and it should be higher than the predicted exposure quantity that is calculated in Tier 1 or T2. Next slide. So you're looking again at the same 2 endpoints, colony weight and reproductive output. And as for the study duration, here you have a 2-week period of in-hive exposure, after which the bees are simply free foraging with no additional food given to them, but they are still being monitored. Next slide. Moving on to solitary bees, we have a specific protection goal, which is based on population abundance. Of course, this is a very different group of bees with many species in there, all having in common that each female makes her own nest, and there is no social structure here. We have based all our protocols on one model species, mainly Osmia bicornis, though some other Osmias could be used. This is because that's where most of the experience is gained, and we've largely based our protocols on experiences from the ICPPR non-APIS working group again, who've ring tested a semi-field protocol and of course looked at other scientific literature too. Next slide. So again, the advantage of these osmias is that you can order them from commercial breeders. You order them in a cocoon stage, which will, these cocoons contain adults that will emerge from their cocoons under suitable conditions. So you can place the cocoons at a test site, and there has to be an excess amount of nest units and also males compared to females, so that these are not limiting factors. You have a treatment group and a negative control, and in the semi-field situation, you would have a positive control too. And the type of crop that you could use, we recommend to use either oilseed rape or Phacelia, or potentially a flower variety, because these bees have shown to at least like those plant species. Next slide. It's important when you put your cocoons near to the test site that the emergence of the adults is timed to coincide with the flowering and also the test applications. So it's the adult females that will gather the nectar and pollen from the test field. And of course, they should be active when the peak of exposure happens. And likewise, only brood provisions after the application should be included in the data analysis, of course. The adult exposure phase would end at the end of the test plant bloom, which could last for about 3 to 6 weeks. After that, females have filled those nest units, hopefully with lots of brood cells with eggs and provisions for the larvae. Then the larvae will eat the pollen and pupate, and eventually the adults will emerge, which gives you time to collect those nest units, take them, harvest the cocoons, and hibernate them. And then after about 1 year, they can be incubated so that you can assess the emergence success. Next slide. So we're looking here at a number of endpoints that will all help us to assess this specific protection goal of population abundance. Firstly, we look at nesting activity, so how many females that have emerged are able to find a nest unit and are active there. Then you count the number of brood cells, the number of cocoons, and finally the number of emerged females and males in the next generation. And all of this will allow you to calculate the population growth rate, which is basically the ability of the population to replace itself, which we find very good endpoint to look at if you look at population abundance. Next slide. So the field study for solitary bees is the highest tier test. It's very similar again to the honeybee study and design. So when you have those test sites, you could also include your osmias there at the same time. A treatment and a negative control group are here. For the starting population size and the level of replication, this is up to the applicant, though we do have some information that suggests that the larger starting population would give a lower variability, which would help you to show a low effect. There is a requirement that at least 30% of the females would have to occupy the nest units in the starting population just before the application. And here the estimated exposure dose is calculated based on the residues in the pollen provisions that are given to the larvae. And these have to be compared to the pack. So this figure shows you the field phase, then there is an offspring development phase that happens while the nest units are stored. And finally, the offspring will emerge in the laboratory, mostly under controlled conditions, about 1 year later. Next slide. The semi-field study, you study the same endpoints with the difference that the exposure phase here is under caged conditions. So this would be a caged exposure condition for about 3 to 6 weeks. The advantage here is that one site may be enough. You do have to include a positive control if you're doing a semi-field. And you have some requirements that would indicate that the activity of the bees is high enough and that they are actually foraging on the crop by showing also statistically significant effect on nesting activity and cell and cocoon production in the positive control. Next slide. Which is my final slide, which is good, I think, because I'm out of time. So we've seen now lots of different higher tier data, and eventually you'll have to draw a conclusion. So there is also a chapter in the guidance document that talks about how to do this. So you assemble all the evidence that you have from your higher tier data set. You weigh all the evidence and you try to integrate it into different lines of evidence. It's very important to assess all the uncertainties that you have there. And then finally, you would draw a conclusion, which, well, it's not so easy, but it's also very complicated study. So they deserve a very extensive discussion also in a weight of evidence analysis. And with that, I give the floor back to Mima for the question and answers.
Okay, thank you, Jacoba, and thank you, Csaba. I think we can go straightforward to the question and questions that we receive, and I will start from Csaba. So, Csaba, the floor is back to you.
Thank you. So there had been a number of comments even before the info session, also during, about multiple applications, how to address it in higher tier tests. So multiple application can be conducted, especially in field tests. In semi-field tests, it's indeed more difficult. Can be if necessary, but not necessarily recommended by the guidance document. How to deal with it? There are some tips in Annex C of our guidance document. Basically, in the PEC side, so the exposure estimation, the MAF concept, the so-called MAF concept, we do not have a MAF value, but the concept is there, is already taken into consideration. So when we establish the PEC, this should be GAP specific. If the GAP is multiple application, then the PEC is GAP specific. And then in the effect field study, if your EED is higher or equal than the PEC, then basically the multiple application is covered by the higher tier effect study. Maybe you need to do something in those cases, increase the application rate, or more attractive crop has to be used. But at the end of the day, a EED value has to be large enough. And with that, this issue is covered. Now I pick some questions which was also during the info session. So should collection of pollen and nectar for residue analysis be done in the same colonies that the biological assessment are done? If yes, wouldn't that be significant additional stress? Again, Annex C gives some advice on that. I do not recall perfectly, but it's talking about a subset of the test colonies has to be used for the exposure assessment, so to compensate this stress somehow. Then the goal seemed to be to have an EED higher than the PEC. This would indicate greater confidence in assumptions that the model greater confidence in assumptions and the models than the actual measured data. It's a bit so not absolutely clear what is the question, but the next sentence clarifies. This seems backward. Why not assume the EED is correct and the PEC was too conservative? So to be honest, the question is not absolutely clear, but I can explain that an EED, which is from the actual effect field study, may not represent the worst case edge of realistic agriculture exposure in realistic agriculture settings. It can be best case solution, best case situation. So that's why we always need to compare it with the PEC. The PEC is too conservative if it's based on tier 1 parameters. Yes, then it's very likely too conservative, but it's not necessarily based on tier 1. It can be based on tier 2. So actual measured data, GAP specific, active substance specific. Then probably I skipped this. What kind of analytical verification is required in semi-field study? No analytical verification is required in semi-field study. It is for the exposure, as I explained, is basically ensured by the activity of the bees in the crop. Then probably I stop here because I take one and then I give the floor to Jakoba. So would large-scale colony studies have a place in the European risk assessment? The study can be used also for adult dietary risk assessment, not only for larvae. Large-scale colony feeding studies, yes. So we are aware that in the US, they use more and more this type of study. The working group has considered this. I think that for the future, maybe they are used. Some more experience need to collect first. So yes, they potentially good study. For now, we are not considering this. However, I mean, the method, what we consider is very similar. The only thing that we focus on the brood. In future, maybe the colony strength also has to be addressed by the study in the future. So I stop here and give the floor to Jakoba.
Thank you, Csaba. So I have some questions related to the sublethal, which I will do first, and then the higher tier questions for the non-apid species. So before the meeting already, there was a question that expressed concern regarding step 2 of the sublethal scheme, where we used sublethal effects that are observed in the laboratory study based on the standard protocols. This step in the scheme, we've had many discussions about it in the working group. In the end, in the guidance document, we try to give as much guidance and instructions as we can, and we give recommendations on how to improve these observations. And we very much stress that it's important that observers are trained, and that because indeed it has a subjective part of this. But we still wanted to use them because all these data are available and are always presented. So it's also a shame not to use them. But it's acknowledged also in the guidance that EFSA sees this sublethal assessment scheme as an initial attempt to include sublethal effects in the risk assessment, and based on the experience that we will gain, adaptations may be needed. So then during the meeting, somebody commented that let me see, that the food intake level has a link to repellency also, implying that, of course, a repellent substance would lead to lower intake, which could also be a good thing, at least in the field situation. And of course, that's true, but it's in the lab situation very difficult to distinguish whether a substance is avoided because it's bad or because it's avoided because bees suffer from some kind of toxic effect that stops them from eating. So really, if that is the case, then it's something that could be studied in the higher tier only, and not just from the lower tier, I think. Then there was a question about the OECD homing flight test, which is only useful to refine an acute oral concern, which is true. And the question is there any other option for a chronic sublethal concern except for a full semi-field or field study? And yes, there are these specific behavioral assays that I mentioned as one step of the scheme. So you could design a study that is similar to OECD 245, but has these improvements that were discussed here to better define the actual effect level for sublethal. So that would be a step in between for the chronic sublethal. Then for the again, still for the sublethal, there was a suggestion to include the PAIR test, so the proboscis extension reflex test, as the standardized test in the risk assessment. For this test, there is still no harmonized guideline available at the OECD, and what we wanted to do here was to make use of the standard designs. So we haven't included the PAIR test yet, but if future research gives indications that it indeed is good and we can study this in a harmonized way, then potentially in future it could be a useful study. Then I think I'll move on to the non-APIS questions. There was a question sent previously which talks about when there will be a development of an exposure assessment that is applicable to wild bees, since the current scheme is very much focused on honeybee scenarios. This is true. It's acknowledged that most of the experience and the research has been gained with honeybees indeed, and we've used the available research as much as possible. But it's clear that in some areas, especially some potential exposure routes for solitary bees, sufficient data are lacking. And in chapter 15 of the guidance, we have highlighted many topics for which further research could improve the guidance, and exposure of solitary bees is definitely among those. There was a question also about, let me go through the list. Somebody stating that it seems that an enormous amount of bumblebees will have to be used in the higher tier studies, whether we have any idea how often these studies will have to be performed. And I can't give you a number there, but I can repeat what Sophie said in the beginning, that this will very much depend on the decision for the implementation plan of the European Commission. Then there was a question that stated, I'm still not clear how higher tier non-APIS studies will be assessed in terms of the undefined SPG. So theoretically, we observe an effect of 6%. Is it 6%? Is this acceptable risk? And what about 14%? So how is the conclusion drawn? And yes, indeed, there is no conclusion. I can't give you a number here either, but I will refer you to Annex C, where there is a section where guidance is given on how to present the results of these studies. So what happens there is that you can tell your risk manager in which effect range the effect of this pesticide is likely to lay. So that gives you the possibility to present as an outcome for each study an absolute measure of the highest plausible risk, but and also which range that lies, and that allows at least a comparison between different substances. So that is very useful and can still help to obtain a more harmonized evaluation of different substances. Then maybe one final question for me, Mima, is that okay?
Yes, even a couple of questions. We
Okay,
still have 10 minutes. Yeah.
Okay. So there was a question about the exposure verification in the higher tiers for bumblebees and solitary bees, questioning whether basically, I think whether a residue collection, residue measurement is always needed. And as I said in the presentation, there are in the semi-field test designs, you don't have to measure the residue level in the pollen and the nectar, and there are different ways to show exposure, but residue measurement is not needed. And then I think I have answered most of the questions. I will address one more question that was sent in before the meeting, which asked about modeling. How can effect modeling be used in view of this new guidance, and what is the level of acceptance of effect modeling by member states and EFSA? Now, of course, I can't answer the second part of the question. I will tell you that, as you saw in Alessio's presentation, effect modeling is part of the Tier 1 risk assessment scheme, where we use GOTS modeling to determine whether a substance shows time-reinforced toxicity. For higher tier, I guess that's what this question mostly referred to, higher tier effect modeling at the population or the colony level scale is currently not used for a conclusion in the risk assessment. But its modeling is quite extensively discussed in chapter 10 also, so I would recommend you to read that part of the guidance. There is still some evaluation and validation of models needed, but we do see them as potentially very useful for the future. So please have a look at chapter 10.6 in the guidance. And with that, I give the floor back to Mima.
Thank you, Jacoba and Chava. So we are at the end of this info session. As a general comment, we acknowledge that there were a number of questions. Maybe we couldn't address all of them because of time constraint, but you can always stay connected with EFSA, and in case you might address, if you have still questions related to technical aspects, you can always use the Ask EFSA tool. In addition to that, there might be also some answer already provided in the public consultation that is also public available, that technical report with all the questions comments received and our reply. Other additional, let's say, support can be given according to the transparency regulation at the time of before the submission of the dossier, because we have like a mandatory to give advice for the pre-submission, to give a pre-submission advice for the dossier, that this was for the implementation of the transparency regulation. So we hope that with this info session we could anyway give we were able to give you the general introduction to the guidance and some details, and of course you can always stay connected to us. So for the moment, I would like to thank you, all of you, for attending this event. So very huge participation. I would like to thank you all the speakers, and this thank you is also on behalf of the working group. Just remind that the meeting has been recorded and it will be available on the EFSA website in the next few days. And also we would like you to remind to fill in the survey that you are going to receive just after the meeting, because your feedback is essential for future events on on this matter, on other topics. So I think we can, with this, we can close the info session, and thanks a lot for your participation again.